So I'm Druid. I'm going to talk briefly about MetaSploit telephony. This is a turbo talk because it is a relatively new project that I'm working on. So I'm going to try to speed through it a little bit here. So basically, what is it? It's some core extensions for using telephony devices. It essentially provides a way for MetaSploit to drive devices like modems, things like that, which then gives you dial-up interfaces to remote systems. What this does is it extends MetaSploit's potential target pool, because traditionally MetaSploit is used for attacking network systems. You set your R host, you target systems that way. What this does is allows you to dial up to a system and launch an exploit at it over the dial-up connection. This lets you target things like vulnerabilities in bin login, your Gettys, pluggable authentication modules, and BBS software, which, yes, does still exist. So what this does is it currently just provides a modem object. It has some methods to create a modem, which will attach to the serial port that you specify. You can send it commands, read your responses back, hang it up, flush the buffers, things like that. There's a few more, but those are all the main ones that you might use if you're using this to develop. There's accessors for the object to configure your modem, which are basically your baud rate, data bits, parity bits, all of that good stuff. All right, so how do you apply this? That's kind of the underlying telephony library right now. So if you want to use this for dial-up exploitation, there is a module for exploiting things over dial-up. It has some methods like connect, dial-up, disconnect, puts, gets. There's also an expect, which uses a regular expression, so you can send something and then try to match something back on a regular expression. And then, like your normal exploits, you call your handler. There's the configuration options for this, which pretty much map to the configuration option accessors that I mentioned a minute ago for the modem object. So in order to make this actually work, because we're doing things a little bit differently than over a network socket, we're actually using a local file socket, things like that, we needed a new type of payload, which basically just interacts with the remote system over this, this dial-up connection. Basically, if you make your exploit available for platform Unix and ArcTTY, then this payload will become available for your use as an exploit payload. There's a test exploit that you can play around with if you just need to verify that your hardware works and will dial up and connect and all of that stuff. It's in modules exploits test dial up. And all of this is in the development SVN tree right now if you want to play with it. As you can see, it's extremely simple. It's basically just uses the connect dial-up method, calls the handler, and then disconnects afterward. So this is how you use it. Basically, you'd set your number to whatever number you want to dial, your baud rate, serial port that you're using, that kind of thing, and then set your payload and run the exploit. This is quickly what it looks like. I'm not going to go over all of that because we're a little bit pressed for time, but basically it dials up and it connects and then drops you to your interactive shell. In that particular example, I logged in manually. This is a scripted interactive dial-up using the expect method that I mentioned earlier, which will match on regular expressions. As you can see, it does the connection. It looks for the login prompt. It sends the username that you have stored in your data store, looks for the password prompt, and so forth. Then once you're actually logged in, it'll call the handler, which will drop you down to interactive mode for your session. Basically, all it does is it dials up, connects. It authenticates through the scripted portion. If you wanted to, you could potentially use these types of methods with the puts and expect and things like that to write a local exploit out to a file on the remote system and then elevate privileges that way. When I was originally implementing this, it's kind of specific to the dial-up library, but I think what I'm going to do is abstract that out to a more generalized expect type mechanism for any of your session manager managed shells. In this way, you can then use it to script your sessions and expand that beyond what MetaSploit really does currently, which is puts it in your session manager and allows you to connect to it, disconnect from it, and interact with it manually. So here's a real exploit, which is a very good example of what type of bug you could attack using this. It's basically pretty old. You can see it's from 2001. There's a bug in bin logins that are derived from System 5 bin login, which a lot of Unix has had, specifically Solaris, which is what this particular exploit is for. Basically, if you provide a large number of environment variable arguments to bin login with alongside your login name, it would still prompt you for the password, but then it wouldn't actually verify that password for the authentication, and it would drop you into your shell as the user that you attempted to log into. What's interesting about this is that everything you're doing to exploit the bug is through the normal interaction with bin login over whether you're using rlogin, telnet, or dial-up. So it's a good example for demonstrating this new capability. It's in exploit dial-up multi-login many-args. If you want to play around with it, works just like the test exploit. You set your number, baud rate, all your modem parameters, set your payload, and then run the exploit. This is what it looks like. Again, I'm going to kind of skip over this because we're pressed for time. But basically, that's what it looks like. Once it executes the exploit, it then drops your dial-up shell into the session manager. So you're probably wondering, well, this is great if you know systems that you want to attack, but how do we find these? Using the same stuff, we implemented Metasploit War Dialer. While I was bugging HD for information on where to put this stuff in Metasploit, kind of came up with the idea for Warvox, and he ran that way with Warvox, and I ran this way with the War Dialer. So now we have two War Dialers. They both work a little bit differently, and they both have slightly different goals, but they're both awesome. So this one, basically, it's your standard War Dialer. It has all the same types of options that you would expect from a War Dialer like ToneLoc or Hacker's Choice, those types of tools. You can detect most of your connect strings and modem responses. Basically, you're still relying on the analog modem to do the detection. And it stores all of the information in your Metasploit working directory under logs wardial. There's two things that are stored there. There's a gzipped marshaled Ruby scan database, which basically has all of the numbers that you're attempting to scan, whether you scan them or not, and what their statuses are. And then there's a ToneLoc style found.log file, which just notes the interesting ones, like connections and faxes and stuff like that. And it can also log to an SQL database. So the options, there's a few more than the exploit options that were available. You can see you have a dial mask, a dial prefix, all of the modem options just like in the exploitation usage of this. There's a log method which tells it whether you're going to log to a file or the database. There's a nudge string for once you connect to try to prompt some information out of the remote system. And that's about it. It's implemented as an auxiliary module. So basically you would use the module just like any other auxiliary module, set your parameters, and then run it. In this particular example, I was scanning for faxes. So you can see that I've got the modem set to fax mode, and it starts scanning. Towards the beginning, it realizes that there's 4 digits masked out of the dial mask, so there's 10,000 numbers to call. Sets up the database in your MSF working directory, starts scanning, and you can see here that on the second one it actually found a fax. So that's what it looks like while it's running. To log to the database, basically it uses the database abstraction layer already available in Metasploit. Basically all it does is it calls a report note method with the type of wardial result. So it's in your Metasploit database with that type. You can search for those, and that'll give you all of your results. Eventually, this should be able to interface with another project that I'm working on called Tidbits, which is the Internet Database for Information Telephony Systems. Essentially, what I want to do is have an online database available for people to go and search for pretty much any telephony system or information system that's attached to a telephony device and answers the phone. The interesting thing about this is I intend to make it public, so I'm sure I'm going to have a lot of anonymous submissions and things like that. So all of those are going to be inserted in basically an unverified queue. The Metasploit War Dialer should be able to query this database for unverified targets, dial those, and verify them if you're set up with a verified account. That way, it essentially turns the Metasploit War Dialer into a distributed War Dialer. So what's missing? basically, like I said, this is relatively new. There's still a number of things that I'm trying to implement. One is direct voice over IP support. The problem here is that there's not a really good digital signal processor and software that will integrate with voice over IP software. This is kind of one of the reasons that Warvox went the audio signal processing route rather than connecting. When we first started looking at, we were working on both of these war dialers, it actually turned out for Warvox's advantage to go this way and do the post-processing audio analysis because that allowed for Warvox to have a lot more capability in batch processing and doing massive scanning. There is one tool called IX Modem which exists, but it uses a DSP that currently only will detect fax carriers. It won't do data. There are other DSPs that exist, but like I said, they're not really tied or architected well for integration with VoIP. I believe the GNU Radio project has most of the components that are needed, but they're kind of geared towards RF. So that's definitely one thing that there's room for improvement. More exploits. I've identified a couple. I haven't really looked at all of these yet to see if they're applicable for use by the dial-up exploitation stuff, but there's definitely more to go there. The one that I showcased earlier is in the development tree now. You can go play with that if you want to. And a friend of mine tipped me off to some Renegade BBS O-Day, so I need to verify if that still works in the current version, and you might see that show up soon. Also, I want to work a little bit on non-carrier signal processing. Right now, it's using a analog modem to do the detection. So you're either connecting to a fax or you're connecting to a modem. This is kind of the same type of analysis that Warvox is doing currently. So I think there's a lot of opportunity for bringing some of the Warvox code back into MetaSploit and improving the war dialer here to work in different modes. So that's about it. Because we're pressed for time, I probably shouldn't take any questions here, but I'll be wandering around if you want to ask me about it after the talk. Thanks.
Test. Okay. So because we're short on time, we want to make sure that everyone gets a chance to talk. I have a 30-minute chunk, and I'm actually have two co-speakers doing two other pieces too. So we're moving really, really quickly. Because of that, we're probably going to cut back on the break time between each track. We want to make sure that everyone all the way up to the end of the track has time. So I'm going to start almost immediately, and we're going to go from myself to JR to Carlos Perez, and from there straight to the next thing. So if you're one of the speakers of the 6, 7 we have left, make sure you're ready to come out like the second your time starts, because we want to make sure there's time for everybody. Thanks. Yeah, you guys, welcome. So I'm going to go exactly for 10 minutes, and then swap, and then 10 minutes swap. So all of our slides should all be integrated, so you can just swap here. So we're actually going to start, I think actually 20 minutes early. So you can go, if you want to do 15 and you want to do 15, we should be perfect. I don't know how long it will take. I'll just go as fast as possible. Okay. Yeah, basically might end up giving people a minute or two to ask questions. Okay. What I want is here. I'll give people one more minute to get it. I think. So I'm just try to finish up that stuff. So that's that. And then let those folks who have getting their talk kind of like but we can talk about more in the Q&A. Worst case, keep going, and we'll buy more time back. So I'm going to get started in just about 1 minute. Just want to make sure the rest of the folks can trickle in. Just Alt-Tab, well, just hit Escape, switch to a different tab. All right, going to get started. We're starting early to make room for the folks who just came in. We're going to move really quickly for the next 3-4 hours straight till we're done. What this kind of mini track is a little bit about Metasploit, what we've been doing lately, some of the project goals, overviews, and kind of barely touching on IPv6, but making it clear what we can currently do. And then a lot of stuff about Meterpreter, both from porting it all to Unix platform, with this gentleman did in about a week with basically no prep work, to all the automation stuff that Carlos is doing and some of the new tools that he's coming up with. So go ahead and get started. I'm going to go in like micro machine guy mode. So if you have any trouble, you can always look at the slides later on or catch me afterwards, and I'm happy to explain stuff. So my name is H.D. Moore. I'm the project lead and core developer of Metasploit. There's actually other core developers, but I've kind of been around probably the longest, since 2003. The other two gentlemen who are going to speak with me today are JR, who's doing the Meterpreter pose export, and Carlos Perez, who's also known as Dark Operator, who does most of the scripts for Meterpreter currently in Metasploit. Some quick facts. So, as lots of people like to argue, we are still the biggest Ruby project in the world. So it's one of those cases where if the Ruby interpreter starts to fail and we don't like what the developers are doing, we'll fork Ruby to make sure Metasploit still is an interpreter for it at this point, because we have more code than them. Second place is Puppet and Ruby on Rails. So if you're familiar with those projects, they're actually still smaller than Metasploit is right now by at least 10%. We've got about 100,000 people who are doing SVN updates via unique IPs to the main Metasploit server every year now. So this number's been moving up from about 55,000 in 2006 to about 100,000 now. So you can see there's a lot of people in this room, a lot of people use Metasploit, so we're really happy the community project is really coming together. A lot of folks are working on it, and we feel like we're making a lot of progress. There's actually a core group of about 20,000 users who update about once a week. So we always see lots and lots of, the same 20,000 IPs updating every single month to our servers. So we know who you are, but thank you. Something we noticed recently was there's 235 books currently mentioning Metasploit. So the project has gotten ridiculously huge. We're mentioning about 65,000 plus blogs right now. Who knows how many Twitter messages here and there. And this is the first conference I've ever come to where the press release, the PR folks, came to me and asked me who my agency was, because we actually have this good message. Well, we don't have an agency, we have you guys. So thanks again for helping us get the word out and kind of giving motivation to our developers to really kick ass and get things done. There's actually about 15 active developers, but which 15 depends on what time of the month it is and who's sleeping and who's drinking and who's going where. So it's a really loose-knit group of folks, but we tend to have about 15 people active at a given time in the project. Let's see how slow I am. Alrighty. So quick goals. In the short term, we want to speed up our release cycles. A lot of folks say, well, you break the Metasploit tree every 5 minutes and the only updated version is trunk. Yes, we do that. Unfortunately, what that means is Valsmith and these guys over here have to find the exact SVN release that actually works properly and save it off for all their demos, and then don't update ever. So we're actually going to try to fix that by having shorter release cycles. We're going to get 3 out in the next month, and kind of go for maybe a quarterly or semi-annually at the very late, slowest release cycle. Overhauling all of all of Meterpreter. So we're actually adding POSIX support for there's work on Mac OS X, there's work on Linux, on BSD, everything. We're actually making a portable Windows install and Mac OS X install. A few folks got a link to the demo of the beta of that. Basically, you can put Metasploit on a USB key. It'll work standalone anywhere. It only required us to patch all of Ruby 191 and all of Cygwin to make it work, but it works now. We're completing the switch to Ruby 191, so we actually get about twice as fast, which is still really slow, but it's Ruby and it's a little bit faster than it was. So if you're really tired of Metasploit taking 10 seconds to start up, well, now it's only going to take 5 seconds to start up with Ruby 191 going forward. And most of our code's done for that as well. We're going to try to change a lot of the console improvements, add some defaults, make things easier for people to use, so you don't have to type the same damn thing every time you use it, and things just kind of work the way you expect them to. Hopefully without breaking anything or making things worse. You can see that we've got a ton of content all on this track, both at Black Hat and DEF CON this year. And like my job is exploit janitor and kind of code janitor, so I have to go combine all the cool things these guys are working on, actually put it into a release and make sure they don't step on each other. So the next thing that we're going to do is actually work on all the work that happened the last 2 months leading up to this, merge them together and try not to break the tree, and then get the 3.3 out. So long-term wise, on the code side, we're going to try to replace both the GUI and the current web version with a brand new web version that's much easier to use, it has cleaner support, things like that. The idea is that you'd be able to have a special special menu from the website, the MSF web version, to do things like browse files on the remote host, take screenshots, do videos, do all your really cool like interpreter automation exploitation, now using kind of a GUI browser interface. So there'll be a lot of neat ways to go through and automate things and set up kind of like little capture portals and stuff all through the web interface once we get that going. We're also going to be overhauling the console, adding it so you can connect to a remote Metasploit instance. So you can have your MSF console talk to a shared server, have everyone share the same exploits, the same everything else, while still keeping your local tools. Tons of automation, tons of automatic analysis, tons of reporting stuff is in the works. For folks who use SMB Relay, does anyone here use SMB Relay stuff? Great. So the problem with SMB Relay is if you relay a connection that doesn't have administrative privileges in your target, you don't get a command shell, you only get an SMB authenticated session. So what we're going to do is create an actual dedicated SMB session type. So if you don't get a real shell, it defaults to an SMB session type instead, and now you can basically have an SMB client on your hijack connection to upload files, download files, access the registry, do all the things you normally could, as well as exploit things like weak service control permissions, things like that, using that authenticated user account. So even if you don't have admin access, we're going to get you something. Let's try to fly through this. We talked about task-based interfaces, basically having a web app assessment UI, wrapping all the stuff that a Frame's doing with WMAP and have a nice configuration interface for that. Ways to build persistent agents and backdoors directly from the UI, hopefully integrate some of the stuff these guys are doing in Metafish and get that whole thing kind of bundled up in a UI. As far as the project goes, our goal right now is to have an industry-wide standard security tool platform for everybody to use that's free and keep it under the BSD license. So the idea is anytime there's a crappy proof of concept tool being released for one particular vulnerability, make sure you can actually add that to Metasploit, maintain that, use it 5 years from now, not have to worry about compilers or headers changing, things like that. So we really want this to be a standard platform everyone can use. We're actually looking at some sponsored feature development. Some companies are saying, we'll pay you this to work on this feature, or we'll actually give you a developer for a week to work on this one particular piece. So we're trying to leverage some of that when we can. We're looking at integrating with other commercial tools, from vulnerability scanners to IPS to IDS to SMS, everything in between, to make sure that if you've got a tool that has some information that we can use, we can leverage that to either make that tool work or take information from that tool to make an exploit work. One good example of that is there's a tool called Netafera, and we were looking at ways to basically take the Netafera agent and actually drop that using any standard Metasploit module. So you can kind of combine exploits with the remote agent system. Lots of documentation, lots of SDK stuff, lots of good goals there. Looking at ways for the end user to be able to script things and automate things easily without actually having to know Ruby, which is going to be a little bit of a challenge. I think we can do it. And finally, actually having automated regression testing and quality feedback if you possibly can. So on the IPv6 side, I've mentioned this on one conference before and in some of the training, but all of Metasploit is IPv6 ready. You support for it in every core library, every socket. We've actually have support in the payloads for Windows and Linux. You can exploit anything over IPv6, pure IPv6, and it just works right now. All the stagers, VNC inject, Meterpreter, that stuff just works great. No IPv4 traffic at all. Is there a question? Oh, no, just someone waving. Howdy. All right. So all modern platforms right now actually ship with v6 on. So if you had a VistaBox, Mac OS X, Ubuntu, Solaris, it actually has a v6 address every time you plug it into an Ethernet port. And Metasploit can now exploit that. So even if you have something like Zone Alarm or another firewall installed that normally blocks these types of connections, you can now bypass that firewall using the v6 address of the device to get your shell, and Meterpreter, VNC, automation, etc. Most admins have no idea how to filter these things or how to manage them. So when you root a box, you can do it through the fucking the v6 address, and the admin will never actually see that in your listing. And the nice thing about this is Windows 2003 and XP with v6 installed won't actually show it in the netstat table either. So it's a great way to really screw with an admin who has no idea how you're in the box. So basically, you can pick an exploit, get an access, all without IPv6. I was going to do a demo, but we're running out of time, so I'm going to fly through this. This is the thing about these linked local addresses. You can only exploit them locally on an internal network. However, once you're internal, you can do all sorts of cool things over v6, and no one will ever see you. One quick thing before I hand it over to JR. There's been a lot of Meterpreter improvements over the last basically month. I had a baby, and I was home on maternal leave, and so I had a baby on one shoulder just hacking away, on laptop on the other, and we managed to port all of Meterpreter to SSL. So the entire interpreter session now is over TLS, including migration. So hopefully once your payload is actually up and running, you never have to worry about some pesky admin seeing your connection ever again. One of the other things we worked on was keystroke logging. So you can actually inject a keystroke logger in MetaSploit into whatever process you're currently in, either the actual what the admin's typing in normally on the desktop, or you can inject into WinLogon and capture all the console login credentials of a particular server or desktop. We also have a packet sniffer that's all in memory now through raw NDIS hooking using the Micro OLAP SDK. If anyone's familiar with the tspeedump that's completely standalone, we use the same library. We have a commercial license for it, and the sniffer is now available to everyone for free. And this is a full-blown packet sniffer for all versions of Windows. It runs in memory. You can run from Interpreter just by typing use sniffer, and it works great. So I was backtracking some botnets and how to use it. So finally, Interpreter is being ported to a lot of platforms. Charlie Miller ported it to Mac OS X using some of Dino's work with the library bundle loader and some of his own work. But it's also being, since basically Charlie took too long to give us code, we're also porting it to a generic POSIX platform. And JR here is going to talk about that, about his process for actually doing POSIX porting of Interpreter and some of the really neat tricks he did in memory to make that happen. So without further ado, here is JR.
So I'm just going to talk a little bit about why Interpreter hasn't actually happened yet on Linux. I mean, I bet at least half the people here are running Linux and have targeted plenty of platforms where it would have been nice to have it. And it seems like it should already be there. I mean, what is it really? It's just a stub that reads a library over the wire and loads it. I mean, that doesn't seem like that should be all that hard. Well, yes and no. So in Windows, the load library, get proc address are all at a known address. There's some hacking that had to be done to get around reading it off of disk. I mean, you've got it as a blob in memory, and most of the things that map libraries, typically the APIs want to read it off disk. But all in all, the infrastructure is there. You hook the right calls, and you can load a library from memory, and it just works. OS X, it's fairly similar. The Mako resolve is at a known address, and with very little code, you can inject a bundle into an arbitrary application. On Linux, FreeBSD, NetBSD, etc., DLOpen is actually a service provided by the runtime loader and isn't necessarily at a fixed address. So you don't necessarily know how to get at it. And the runtime loader will actually resolve references to DLOpen, DLSim, etc. at runtime. So unless you already have a relationship with the runtime loader, so to speak, you can't actually get at that. And not to mention that you aren't guaranteed that the application that you're compromising at the other end is actually dynamically linked. So Scape actually wrote a paper on it and what would be involved, and didn't sound like a whole lot of fun. And so given that it's not easy to talk to the runtime loader, how do I provide the necessary services? Well, I cheat. So basically, with what I've done is I've incorporated a full runtime loader into the initial stub, which actually loads the Interpreter runtime loop and the libraries that it depends on, libcrypto and libSSL, once it's injected by the exploit. So you can, in principle, actually launch arbitrary applications doing this. They have to be position independent, otherwise it's a destructive load, but I'll talk a little bit about that later. The nice thing is it's now completely decoupled from the application, and you're limited only by the application binary interface to the system calls. So anyway, I'm getting back to when I actually first started looking at doing the Linux Interpreter a couple of weeks ago. I'll just talk a little bit about that, starting with a pre-existing library loader, what was involved in the ELF runtime loader, and next steps. So first of all, I just took the Windows Interpreter And wherever possible, I just shim the APIs and the error returns to share as much code as possible. The idea being that the current developers can just keep the code as is. Any bugs fixed will get fixed will mostly translate to the POSIX interpreter. And I just assumed that that would make it easier to maintain. That was fairly tedious, but wasn't obviously particularly interesting design work. Now, as AHD pointed out, everything's running over SSL. That means that you need to have the SSL library. Initially, he was using Polar SSL, which is nice, which is nice and small, but doesn't have the right license. So now he's using OpenSSL, which libSSL depends on libcrypto. These are kind of bloated, so I actually put zlib into the stub as well, which reduces the footprint of the libraries by about 60%. And so it's effectively a very crude packer. And then I took previously existing code, the 32-bit Linux library loader, and was initially going to work with that and just sort of accept that. And I realized it had some limitations. First of all, it has to find the base of the libc shared object in memory, and which is actually pretty easy on Linux. You just open up the proc, and you get the mapping of the libc, and then it resolves the symbols in your libraries against that libc. Well, and anyway, mentioned that here. Well, on other operating systems like FreeBSD, OpenBSD, you don't necessarily have that mapping. FreeBSD now has a syscontrol interface, but historically you had to go through KVM, which meant that you either needed to be root, which kind of defeats the purpose, or you needed to have a setuid binary, which also defeats the purpose because you have to spawn a separate process to go read that, which is setuid, kind of stupid. Also, like I mentioned earlier, if you're relying on finding the base of your libc, you can't work with a statically linked application. And it also assumes that your payload will resolve all its symbols happily against the application's libc, which will probably work in general, but I mean, it's just one more thing that can go wrong. And you have to ship any non-libc functionality anyway. So, like in this case, SSL, et cetera, you can't rely on any libraries in the application's address space. And these are specific issues with it. It was 32-bit Linux only, and it didn't support the most recent way of hashing symbols in glibc. So anyway, I decided to sort of go with an off-the-shelf solution, so to speak. I took FreeBSD's runtime loader, ELF runtime loader, rewrote it to mmap anonymous memory, copy in the libraries from the decompressed buffer, and then call back various stub code to map libraries to load. So now, the nice thing about this approach is porting to different platforms is just a matter of extending the C runtime for platform variations. So FreeBSD has its _start interface. glibc on Linux has a slightly different one, different calling convention. It has a libc_main_start that has to be shimmed in, but by and large, it's all just the same code, and there's very little variation across platforms. There's a good chance that all the BSDs may actually just be able to use the same code, and the C runtime interface doesn't vary at all. Well, now the next step is, the question is, what is this really? I mean, it isn't just DL open. It's actually a generic user level exec. This isn't new. Haven't done anything terribly original. Grug, Scape, and others have done some version of it before. It isn't clear to me that any of those were cross-platform, non-destructive, i.e. didn't displace the existing sections, and robust variations in libc. So what's neat about this is one could in principle run arbitrarily many applications. They'd have to be cooperatively context switched because the whole point is the OS doesn't know about them, but basically you put hooks into the libc that you ship over the wire with it, And so up to the amount of space that you have in the heap, you could have your xterm, your Emacs. Well, Emacs might not play nicely. Emacs does some weird things, but VI, etc., all running inside your hacked Apache heap, which I think is actually, I don't know how useful that is, but I find it pretty funny. It requires some extra work. There'd have to be a stack allocated for each pseudo process. You'd have to make exit, not actually exit the process, because that would kind of screw up your session. Fork, you wouldn't want to actually call into fork and exec similarly. So anyway, this is just a diagram that's kind of hard to read that shows you what the stub looks like. The POSIX elf interpreter is just zlib. The blobs, which are shown over the right, which is the interpreter core, libcrypto, libssl, and libcommon, which is just a diet libc. I mean, don't need all of the 1.2 megabytes of a glibc. The elf runtime loader, and then just a simple decompressed loop and link. So anyway, the interpreter core is just a standalone position independent executable, so I can actually test it on the command line independently of this process. So where do we stand now? The event loop works just fine on Linux. It can be loaded into an arbitrary address space. Next step is, I'm not sure what the status of Charlie Miller's work is. I mean, last I knew there was just the bundle injector. We could just shim the bundle injector into the POSIX interpreter. That would facilitate maximal code sharing. So now you have, you just share one interpreter code base amongst all the platforms. It's been tested on 32-bit and 64-bit x86 FreeBSD and 32-bit x86 Linux. There's some cleanup needed. I did it over the course of a week, wanted to get it done by DEF CON, and things got a little bit hasty in the process. But I'm in the process of getting it into the Metasploit tree. I don't have commit privileges, so I'm just bit by bit pushing in patches, trying to avoid breaking things that are there now. Any questions? Well, next step.
Well, hello everybody. My name is Carlos Perez, also known as Dark Operator. I'm one of the members of the Paul.com Security Weekly podcast. I'm also an IT solution architect during the day, working mainly in the area of virtualization and security in network infrastructure. And during the night, I spend almost all my time scripting the interpreter and running post-exploitation, and how I can help the community once you get, as a pen tester, you penetrate that box. How are you able to leverage the most time that you have available to get the most bang for your buck? So if you go to my website, darkoperator.com, you'll find a lot of scripts that are not part of the framework, but might be useful to you also. If we go to Meterpreter has done a lot of advances. The framework API is completely very well written. It is very useful. I have tried to port my Meterpreter scripts to other frameworks, and it has been a complete nightmare in terms that in Meterpreter only to execute one single command, it is a single line of script. If I try to do it, let's say if another brand of framework that I have to pay for lots of money for, it took me 67 lines of code just to execute one single Windows command and get that output. So the advantages of scripting interpreters for you to save time and automate your post-exploitation, they're wonderful. That's why I love Interpreter a lot. You're not limited by the API alone. In fact, you can leverage the OS commands, run those commands, take the output out of those shell commands, either be in Windows or with the new Interpreter payloads are going to be for Mac OS or for Unix or Linux, you can take that output, process it, use regular expressions and process that. Also, you could upload the necessary tools to the target, run those tools, then delete those tools and do the cleanup afterward. Or you can use the OS own scripting capabilities. Right now, if you go to my website, you will find a script called browser enum, and most of the tasks that I'm doing for enumerating stuff inside IE, I'm using just pure BB script, WMI scripting to get that information. Some of the stuff that I've been working, you will see that I will leverage. If the target has Perl, I'll leverage Perl. If it has Python, I'll leverage Python. So you're not limited only to the API. You're only limited to what you can imagine and how mischievous you can be thinking of ideas on how to do that post-exploitation on that box. The scripts can be run upon session creation. And the main purpose of my talk is for you to think tactically. Many times I have seen many people send me scripts, send me stuff, and when I run these scripts in my lab, most of the time they break. Debugging these scripts have been very kind of hard. So I started preaching to a lot of people how to automate their post-exploitation interpreter. So I decided just to condense all of that information into this, and the line is just think tactically. Don't think like I'm going to just run a series of steps, but think, why am I running those steps? Are they necessary? What privilege do I have? In fact, not all versions of an OS are the same in shell. If you're running against a Windows XP machine, it's not the same as a Windows Vista machine. It's not the same as a Windows 7 machine. The commands in that machine will change. In fact, I've seen Windows commands that may change. Even if the same command is present in all versions of Windows, the switches vary. Some will accept, they're not case sensitive in one version, and another version they're case sensitive. In one version, they don't need spaces between the options. In another, they do. So you got to be very careful and test depending on the OS version. Also, being local user is not the same as being as a domain user. So you have to check in your post automation what exactly do you want to do. How do you want to pivot inside that machine, and you want to know what you're doing under what privilege level, so you know what actions to take. And that way you can be even more stealthier and get more bang for your buck of the work you're doing. Also use environment variables. I have seen many people go and tell me I have run this script several times against this target network and it's always failing. I take that same script, take it to my lab, it is working perfectly. The only thing is that they're using full path. I just changed their script to a variable, use the temp variable, use the WinRoot variable. They run the script, everything was working. What did the sysadmin do? During this hardening procedure, they changed the location path of those folders in Windows. So using variables is very important. Also using these variables will make you, if I'm running a system, my temp location as system is going to be different as my temp location if I'm running as a regular user in a box. So this will give me the advantage of where to put my data temporarily for when I need it. Check for countermeasures. If they have countermeasures, you have permission during your pen test to take them out, take them out. If you don't have the permission, bend the rules, work around them. Also, use random names when you're creating files on the target. I remember a lot of times people going, I'm creating this script for this class. All of my students were running it, never worked. They sent me the script, I just check it in, and all the students were overwriting the data of each other in the target machine. Then I had the pleasure of doing a pen test where I got 4 shells in one single box all at the same time. And when I got those 4 shells, the advantage that I had was I was not overwriting my own data because I was using random names for the files that I was creating on that target. Also, clean up after yourselves. There have been many times where my company has been called to go in and check the other work that another pen tester have done, and I have found all of their toolkits, all of their tools, their scripts, and everything on that box. And I can go to the client, well, they just left this for the next guy who comes in, so please clean up. Use functions, keep your code as modular as possible. Every time you're writing scripts, it's a lot easier if you have already a function already pre-made and you just copy paste that function, use it time and time and time again. Do not reinvent the wheel. On the versions of Windows, as I mentioned later, you have the availability of commands. Each version of Windows has different countermeasures. Different features are installed in different versions of Windows. Right now, if I'm on a Windows 7 box or a Windows 2008 box or a Vista box, and I want to do something like wget, I have bitadmin, where I can go through a proxy, HTTP, download my tools. I do not have that in Windows XP. I don't have it in Windows 2003. So different features are installed on different versions of Windows, so take advantage of them. Location of files. In a Windows 7 box, Windows 2000 box, you cannot copy files in certain folders as you can in Windows 2003 and Windows XP. So you got to be careful when you're doing your scripts to check for the OS version. And according to that OS version, take your commands. You decide what commands are you going to run in that target. And also, as I mentioned, different versions of Windows, same command, different switches. Some are case sensitive, others are not. Some require space, others don't. Level of access. Being administrator is not the same as system. If you want to run incognito in a Windows 7 box, Windows 2008 or Vista box, you have to be system. If you want to run hash dump on a Windows 7 or Windows 2008 also in Vista, you have to be system on that box. Microsoft's getting smarter and they're changing their feature set in their API calls. So we, as attackers, also adapt to this. Domain access sometimes it's a lot better than being system. If I pop, well, that sounded wrong. If I penetrate a SQL 2000 box and I get inside and the administrator make the mistake of running the systems in that SQL box as a domain admin account, most of my work is going to be done through SQL. Why am I going to go directly to shell and be system on that box and not leverage that advantage of being a domain account that I can then touch other boxes inside that domain? Using, as I mentioned, using environment variables here, you can see the API calls that I can use for client.fs.file.expand path, where I can expand that path. If you're executing a command, you can place your environment variables inside that command just by calling cmd/c, and CMD will do the work for you of expanding that variable when you're doing this attack. Also, getting environment variables are very useful when you're doing an enumeration of a target. Chris Gates can talk about it when you get into a box, either being it Windows, Linux, or Unix, and you see the variables, you're going to know if that box is running Oracle or not. You'll see if that box has Perl installed or not. You'll see if it has Python installed or not, and you can take advantage of those tools. In fact, it will even be able to see even the version of Java that might be installed in that box. That can be very useful to you just by checking those environment variables. So very important information to have when you're automating your tests. Also for finding the best place where to locate or place your files. Do not use static naming. If you get several shells and you run your scripts in run, you will overwrite your data. Also, if the sysadmin is smart and he's playing with Metasploit and he knows that that script will create a file called tmp.exe, he's going to create rules in his hips, or the AV vendor will create rules that will lock for tmp.exe. So be stealthy, be mischievous, think of Loki as your god when you're doing this kind of work. Also, offensive to obscurity. By doing this, you'll also being obscure. I use the ran function. I have friends that use the MD5 function inside Ruby to create their names. You can use whatever you want as long as they're not the same and they're random. Check for countermeasures. Check for AB, hips, firewalls. Punch holes through them if they won't let you disable them. If setting listeners in a Windows box, check for the firewall. I have seen it time and time again when I'm teaching or co-hosting penetration class, and I see the students, all of them going crazy, setting up their listeners, their netcat. They're trying to connect, they're not able, and we instructors are laughing because we taught them 3 slides before, 15 minutes before, that they should check the firewall in the system. If the admin is smart, and right now, not all of them are that smart, but they're getting smarter because right now what Redmond is doing, they're putting it as default, having it on, so they're taking the decision off the admin. So check for that firewall, punch holes through it. You'll see several scripts of mine, like get GUI or get telnet, that you will see instructions there that you could just take, modify them, while I punch holes in those firewalls. Also, check policy settings. If you check my check countermeasure script inside the SVN, you will see how I can enumerate the policies in that box just by using the same commands that the Windows administrator might use for checking those GPO policies. It will detect any version of current HIPs. They have a very large list of HIPs, firewalls, antivirus software, and if you can give it the option to kill it, in addition to detect it, it will also give you all the settings for that Windows firewall. So if you want it, and it will also check for UAC in the case of a Windows Vista box or a Windows 7 box. Clean up after yourself. If you get permission, in addition to deleting all of your uploaded tools, clean the event log, change maze. In fact, when you're changing the maze of file, I prefer to copy it from another file just because I want to make the forensic team or incident response team life more difficult. I want to test their skill set. So many times you will see, like in my WinEnum script, I'll just take the check disk maze and I'll copy it onto the files that I use. When they go in, the first thing that I have seen many forensics teams and incident response teams trained to do is check for the default date that gets set when you clear a maze. But if I didn't do that, and I set another maze from another file that is in the system that probably was run 2 or 3 months ago, I'm making their life a lot more difficult. And also, I'm making my client a lot smarter because right now they will have to improve their techniques for handling incident response. Kill any processes not needed. I have gone many times into a client and I found netcat listeners that were done from pen tests that were done 1 or 2 months ago, and the netcat listener was left on that client machine. Backdoors left, and the process is in memory. The machine has not been rebooted. They removed the files from the file system, but they left that process running in memory. If you're going to use any of these tools and you write your script, make sure the script checks the processes and kill those processes as you leave. I gotta give special thanks to HD Moore and the Paul.com crew. In fact, the Paul.com crew is the ones that are giving me the wicked ideas of how to be a bit more evil when I'm doing my scripts, and all of my work is done on top of the shoulders of the work that HD has done and the rest of the MetaSploit team. Thank you.
So just one quick note before we go on to the next talk, which is Mike Kershaw talking about his awesome Lorcon 2 and wireless stuff. So stick around for that. We'll still be moving really quickly. Mike, if you're ready, awesome, sweet. So let me just kill this one slide and when we're done. So basically, MetaSploit right now depends entirely on its user base for community, for inspiration, for development, for QA, for testing. Without the feedback that we've been getting, without the people testing it and actually using it, the project would have been dead 4 years ago, and this talk wouldn't be happening. So thanks again to the entire community for everything you've done. And one more thank you to the DEF CON folks who put this together, Ping, Jeff, Nikita, Val Smith for railroading it all through, and for all the folks who actually took their time out to come to the talk, and for the folks who came up here to go speak. So thank you, and here's Mike. Thanks. We don't have to hurry because I think this is free 20 minutes we need. Yep.
All right, we All right. Guess we'll get started. I'm Mike Kershaw, a.k.a. Dragorn. I wrote and co-wrote Lorcon with Josh Wright. So I'll get through this pretty quick since we're a little short on time. So MetaSploit, you might not have realized, is actually a time machine. It is not a hippie good doer time machine. But when you get to bring back really cool weapons of the past with you. So seriously, Wi-Fi is shared media. Remember shared media? It was the 80s and the 90s. It was a lot of fun. Everyone's connections were visible to you all the time. TCP hijacking, local DNS hijacking, all that stuff. Yeah, that's all back. It's all in Wi-Fi. But everyone uses encryption, right? I mean, everybody has to be smart enough to do that now. I mean, you'd never ever take your system from work to an insecure network somewhere. I mean, that'd never happen anywhere, would it? So, what are we going to do with this? Lorcon, it's injection library that Josh and I wrote a couple years ago. Lorcon 2 is the latest version of it with a new improved API that's actually a lot more pleasant to use. MetaSploit, Racket, which is a very fast packet assembly and decode library in Ruby, and the general Ruby network libraries like NetDNS. So, why did we do Lorcon? Writing the same code over and over again sucks when you have to write all the control code. Writing apps for every driver with separate quirks also sucks. Writing apps for every OS sucks. Hopefully, Lorcon doesn't actually suck. Unfortunately, the first version of Lorcon kind of sucked. The new API is simpler, it's cleaner, it's modeled directly after PCAP, so it should be a lot easier to use. Any app that uses PCAP, if you just open the Lorcon header, you'll see almost every function you've seen in PCAP, just prefixed with Lorcon instead of PCAP. So, for injection. Right now you need Linux. Right now you need a Mac 802.11 supported driver. You need a new kernel. That probably means 2630 or even the wireless testing stuff. Lorcon 2 will eventually expand back up to support Mad Wi-Fi NG, AirPCAP TX on Windows and whatnot, but there's just wasn't time before the con. There's no good way to do injection on Mac right now unless someone wants to write a user space USB stack. If someone wants to write a user space USB stack, come talk to me. Seriously? So, doing it with Ruby. It's a really simple interface. You just load Lorcon, you create a new interface, or you create a new Lorcon device context, tell it what interface you want, and you open it in injection mode. It figures out how to do it, it figures out what driver you're using, it figures out if you need to make a VAP for it, figures out all of that. And then you just loop through the packets. You get the raw .11 as a byte stream in Ruby, or you get the .3, which is the data frames translated to look like Ethernet. So all the existing libraries that use Ethernet in Ruby, you can feed them wireless packets directly, decode them like they were, like it was a standard packet before. So you just do, packet.3 gives you the Ruby, or either gives you the .3 translation. You dump that into Racket, grab the TCP sequence right out of it, make packets the same way, create a new Racket packet, create the layer 2 stuff, create TCP context, IP context in it, do whatever you want, put a payload in, and then you just turn it into a Lorcon packet. So you make a new packet, you turn the .3 into the what you just created with Racket, you set the .11 unique attributes like the network ID, and if it's coming to or from the access point, and then inject it, and there you go. So what can we actually do with this? Well, now that it's really that easy to decode .11 data and manipulate it, why aren't people doing it more often? It's really only marginally more difficult to make the awesome old attacks work again, and I think we just forgot how great some of them were. So we control layer 2. We don't have to own the internet, we have to own your internet. It's just as good. DNS spoofing, yeah, that's real easy. ARP spoofing. Haven't we done TCP spoofing before? Yeah, we have. Toast presented it at DEF CON about 5 years ago. Airpone. Why isn't everybody using this all the time when they're attacking a wireless network? Really, it's not just for shock porn anymore. And if you don't get it, ask the person next to you. They'll be more than happy to explain it to you. So, TCP hijacking. It's a standard layer 2 attack. TCP is only as secure as it is, such as, air quotes, because it's a random sequence number. When I'm on your layer 2, it's not a random number anymore. Any stream is subject to abuse. So, standard TCP hijacking methods. Same as it always was, just glide through it real quick. You see the handshake go through, you see the client request a web page, you go, oh, well, that's the sequence number it's expecting, you hop in before the server replies, send whatever you want. Close the connection when you're done. The server's far away, we're really close, that means we should be able to beat it pretty handily. So, what does it really get us to do this? It gets us arbitrary content replacement for anything a user does that isn't encrypted. And you can spoof landing sites and rewrite SSL if you want. You can rewrite JavaScript. Come on, SSL solves everything. I mean, users would never pick something dumb like, sure, I'll accept that cert all the time. I mean, users never have any problems like that. I mean, obviously it wouldn't happen. So this makes life really hard for users, and of course they're going to make bad decisions. The operating system doesn't really help them. Cryptic, do you want to accept this? Oh, if you're not a techie, you don't know. So we're using layer 2 to create a layer 8 problem. Even smart users can't beat ODay. If you trusted that website, yeah, too bad. Now that flash file you were looking at is the latest MetaSploit payload, or any other browser exploit, or browser autopwn, or any other TCP service exploit, like, if there's a nice exploit for POP3, replace their email stream. It's like Metasploit, but a little bit sneakier. So we can replace content, but what do we do now? Pretty much every website includes a ton of little JavaScript helper files. If you look at a session with Firebug while you're browsing, you'll see it load, 15, 20 files. Or Urchin for Google Analytics, or jQuery, nice standard file names. So what do we get if we replace them? Arbitrary execution inside the security context of the website people are looking at. So I'm in your browser, rewriting your DOM. Once we get in there, we can do anything we want. All your HTTP links are now unencrypted. All your forms are now logged. All your content's rewritten if I want. I can include other JavaScript. I can include iframes. I could use Kaminsky's socket and sucket code from TorCon a couple years ago. Pretty much any fun you can think of. I mean, just replace the content anywhere you want. So this really matters, but because local replaces fun. But who here read Snake's VPN paper a couple weeks ago? Hands? Anyone? Not nearly enough people. You need to go read this. Short version is you can fake out the browser, and if you can replace the TCP stream, you can tell it to cache JavaScript. If I own your TCP session because of Wi-Fi, I own your HTTP content headers. When I own your content headers, I can tell you cache this file for 10 years. So if you go to Twitter from Starbucks and then load one of the helper JavaScript files, you feed it a spiked file with AirPwn that loads an iframe in the background, tell it to cache for 10 years. When they take that laptop back to corporate network, behind all their firewalls, behind all the protection, and go visit Twitter again, it's going to load the cached copy off the hard drive, and you've got execution inside their corporate network. So the browser will keep this and use it every time until they clear their cache or reinstall their system or trigger something else that causes it to update. So you can load arbitrary code later. Just have your cached JavaScript dynamically load something every time it gets run. Of course, this would never work, though. I mean, users would never go to Twitter at work, right? So you could also, instead of replacing all the content, cache a staging.js, which just loads the original request for us. Anything else we want to load with it. We cache the little staging stub, and then it gets loaded every time again, and we can change the payload whenever we want, whenever the user reloads. So for a Metasploit module, it's actually not vaporware. So how do we implement this in Metasploit? Lorcon 2 exploit module and a threaded server module with regular expression matching for the URLs, a YAML config so it can load files from the hard drive or strings that you give, and you pretty much give it any data and it figures out what to do with it. If you give it one with HTTP headers, it'll use all the ones you gave it. If you give it one with nothing, it'll generate appropriate ones for you. The demo gods have never smiled on me, so you get screenshots instead. Just as simple as all the other Metasploit modules. Load up the AirPwn module, set the interface. I rename all mine based on what kind of card it is because I've got 40 billion wireless cards, but Alpha 0, Wi-Fi 0, WLAN 1, whatever. Set the response. In this case, we're just replacing every web page with hello, we're Metasploit, sucks to be you, and run. And it'll grab any HTTP request headers that come by and replace them. Ta-da. So, but why limit us to just HTTP? We could hijack IMAP and replace email. Anything else TCP, or why not do UDP? DNS is UDP, that's convenient. It's way simpler than TCP. Downside is right now the code I've got can't reliably win the race against DNS servers that are on the LAN with you. But if your DNS servers are beyond your gateway, it's really, really easy to win that race. So that doesn't get us bailiwick or full domain ownage, but it does get us targeted per user replacement of any host name we want, along with including host names local to their LAN. So you could take some domain name local to a target's private network and suddenly redirect it outside the network where we can capture everything they're doing. So DNS overwriting is also just that easy. Create a net DNS packet with Ruby, dump the racket payload into it that we got by grabbing the packet with Lorcon, set the response header to 1, take their question, reflect it right back to them, set an IP we want, bounce it right back in with Lorcon, and there we go. So what's next for this? Restoring old Lorcon drivers, adding WEP encode and decode, that should be really simple. It just took time I didn't have. Adding WPA PSK encode, that's a little bit harder. You need to both have the PSK, the network name, and you need to see the user associate. It's a good thing we can't create packets at will on a wireless network now and kick users off and watch them rejoin, isn't it? Need to actually get a release of Lorcon 2 out the door, and need to start looking at adding some non-802.11 stuff like Zigbee and Bluetooth to it. Can improve the MetaSploit integration. There's a lot of layer 2 injection stuff in MetaSploit, like the new DH client and whatnot. No reason that won't work over wireless. No reason we need to do all the decoding in C, so we can do a Ruby native .11 library. And then there's some general layer 2 handlers we can do to make things a lot simpler and link with payload generation of other modules like browser autopwn and the images and whatnot. So let's mix this up a little bit more. What happens when you get 2 packets in the same window with overlapping data, same sequence number, that hit the stack at almost the same time? In Linux, you get the combination of the non-overlapping bytes of the short packet and the long packet. That's interesting. So what does HTTP look like? It looks like a lot of headers that come back. That's like 270 bytes of headers. What if we had an overlapping packet with really short headers that we collided at the same time? So we send an overlapping fragment that has just enough headers to get by and a JavaScript include. You end up with something that looks like the following, which is your JavaScript running in the page without ever knowing what the page originally was, combined with the remnants of the previous headers. But we can fix those. Just open it up with open up the document inner HTML and look for the double carriage return and clear out the junk headers from before, and the user will never notice. There's a few problems doing this. So there isn't quite a Metasploit module for it yet. We don't know the content length because we haven't seen it yet. We're beating the content length packet. We don't know the length of the original headers, but there's a few ways around that too. So if we've seen the user request before, say a JavaScript helper like Urchin, we know how long the headers are for the server that's sending it. It's going to send it several more times, and we know where the data begins. So we can craft a overlay packet that's perfectly matched that injects JavaScript at the beginning of the page. Or we can just take a wild-ass guess at it. We can inject an overlay immediately. We can set no content length so the browser keeps waiting. We can remember the source IP and source port pairs for that. Or I'm sorry, source IP and destination port pairs for what we overlaid. Wait for the real response, read the length of it, and then send a fin to shut down the connection when the full data that the original server was sending has been sent. We can also use the same trick to append to TCP streams. What does an HTTP 1.0 stream look like? For starters, it looks like HTTP 1.0, which is unlike my example, so I forgot to update these slides. But it basically looks like, response OK, headers, data, and a fin packet. What happens if we beat that fin packet to the client? It means we advance the sequence numbers. The real fin gets discarded, and we get control over the TCP stream. We can keep appending however long we want to do. Script includes after the end of HTML work just dandy in most browsers. It really doesn't seem to care that you're not in the page anymore. So now you can inject content at the end of pages without ever knowing the original content as well. So the limitations on that is that winning a fin race, especially on small responses, can be really hard. I've only seen it work about 10% of the time, maybe even a little less. It really pisses off HTTP 1.0 because it expects the connections to be streaming so that it can do more than one request at a time, and that doesn't work anymore. And you can't control the caching attributes, so it's a one-time attack, but it's still pretty useful. And wow, I burned through those fast. Woo! But Q&A, if anybody has any questions. I know I kind of hammered through those quick. Wasn't sure how much time I'd have. The Lorcon 2 codes at 802.11ninja.net, and the Metasploit patches will be coming soon as soon as I actually get them to HD. So, I don't know. Got time for a couple questions if there are any? Anyone? I don't see any hands anyway.
Hey, just so you guys know, we are not David Maynard. We're sort of flipping the schedule because we're going quickly. He's not here at the moment. This is going to be Metasploit Autopsy, reconstructing the scene of the crime, and then we'll sort of get back on track with probably Maynard next, and then Dino. It'll probably be next. He's not with me, so we're just take the lines. Autopsy is going to go on right now.
Where are the inputs at? Where's the inputs at?
How much time did you have? We had 30.
Yeah.
We good?
Yeah. We're going to do this super fast, too. So I'll give a brief introduction before we even get it going, but we did 70 minutes of Black Hat, so we're going to just fire hose it down you guys again. And if you have questions and such, just come see us after.
Are you gonna? There we go.
Let me just blow this up.
All right. What's this? All right. All right, we're going to get started. Just so we're going to keep with the tradition of going quickly here. The talk's not the David Maynard talk, obviously, as I said. This is Metasploit Autopsy, reconstructing the scene of the crime. That's not important. So why don't our slides match yours? This is a little graph we did. Basically, HD went on a kick sort of after we submitted our slides to Black Hat and such, and we had a lot of free time on his hands, and so he added a lot of things like SSL, changed the loader, and a bunch of other things. So that's a very scientific graph of what's going on. So that's why we were updating our slides and our tools up until last Friday. So here we go. So I'm going to hand this off. This demo is a little unique here. We believe in live demos. Yeah? Oh, you can talk in that.
All right.
So we believe in live demos. And so the demo gods haven't been with us on this track yet. We're going to hopefully change that real quick. We're going to pop this box that the slides are running off of. It's natted to the host only, so please don't try to replicate this on our machine. It won't work. And then we're going to sort of go from there. So,
All right. Peter just pretty much said it all. We have our slides running off this fresh SP3 install, and we're just basically going to pop it with Meterpreter. Set it in lieu of time. We just set everything up already. All right, so we're just going to do a few example attacks that a normal attacker would do. First, I'm just going to do a normal execute to get a command shell. All right, and just some things. I just want to see what users we have on the system. Also, I'm going to do a netstop themes just to show you guys that we're actually on the system. See themes go away. It's all pretty much from that standpoint. Also, we're going to do a process listing, and also let's do a hash dump. Apparently everybody likes hash dumping, so all right. And that's pretty much it. We're going to disconnect, and you guys will see that later in our talk how we're basically going to be able to see exactly everything I just did, hopefully, if the demo gods are with us. Apparently they haven't been with Val and other guys, so let's hope that's not our case. All right, so we're just going to go straight back into our presentation here. All right, so real quick, we have a problem. Interpreters can reside completely in memory, and if we did traditional disk forensics such as DD, and then we tried to look at the actual allocated disk in DD or NCase or something like that, we wouldn't actually see that. So we're going to show you guys basically how we can reconstruct, and when I say interpreter session, I mean exactly what I just did there, and that's going to be our interpreter session. And our solution is going to basically acquire the exploited process space using this tool that Peter will get into in just a minute called Memorize. And we're basically going to parse out the interpreter protocol that it uses for its network communication. And you may be saying, oh, it uses OpenSSL. We'll get into that in just a minute. But we're going to reconstruct the entire interpreter. We'll call it a crime scene just because we're keeping with the CSI type stuff and the autopsy and all that goodness. So that's pretty much it for now.
All right, real quick, Memorize is a tool. It stands for Memory and Analyze. If you put the two together, you get a really cute name. And obviously, we had a really big budget for our marketing department to come up with that. So we're pretty proud of that name. Basically, it has the ability to do a lot of enumeration. It does it all in physical memory, minimal to no API calls for all of these things you see up here. You get all running processes. For each process, you will enumerate the handle table. We'll enumerate the memory sections, which is key to this talk. We'll enumerate the open ports, connections, things like that, strings per process. We can also enumerate loaded drivers. We do rudimentary hook detection. We'll do physical memory acquisition if you want, or more importantly, physical process acquisition, which is going to be what's loaded into the process address space, and that is going to be everything that process is utilizing. So that's sort of where we're going to go from with this tool. It has the ability to work on live or dead memory. It'll utilize the paging file if necessary. We support an array of operating systems. 64-bit support's coming in September, and it will remain free and downloadable from our website, so don't worry about that changing. Process acquisition. All these slides are available on the Black Hat website, by the way, so when we skip them, just go there, and they're pretty beefy, so you can sort of read and follow what we're doing. So process acquisition, what Memorize does rely on. Memorize relies on the physical memory access. That's one thing we'll discuss coming up. It also has its own virtual to physical address translation engine built in. I'll scare you with a really cool image of how that works. I won't go into details on it, but it is a nice image. Memorize does not rely on attaching to a process with a debugger because we don't debug. It does not rely on opening handles or handles to processes or threads. We make very inconsequential API calls. And we're not relying on the virtual memory manager in the sense that we need them to do our translation. We'll actually do the translation. And if you think to DR6 rootkits, they won't work on us either because we're doing our own virtual to physical address translation. So it's a nice little benefit. The requirements for process acquisition utilizing Memorize are the following. We need access to physical memory. This is pretty trivial. It was written about in FRAC. We're going to skip these slides coming up, so just brace yourself for me to flip through them. Ability to find all processes has also been talked about previously. There are talks we'll sort of touch on that. And then we need to parse memory sections, and that's important because Windows uses a structure in memory to represent the virtual address space of all processes. If we parse this structure that represents the virtual address space, we have the virtual address space of that process, which includes injected DLLs, interpreted binaries, things like that, shellcode stack, injected threads. Here's how we open physical memory. We open a handle to device physical memory. It's rather trivial. It's an API call. Windows 2003 Service Pack 1, we actually have to install a driver to open that handle because it's restricted to ring 0. But from Windows 2000 to 2003 Service Pack 0, you have the ability to open this handle from userland. This handle does allow us to read from physical memory. Here's our really cool translation graphic. Yeah, that's all we're going to talk about. Memorize does this all internally, so you don't really have to worry about it, but we thought it was cool to show. So once we have physical memory, access to physical memory, we are going to translate that virtual address to some offset within that section object. We're going to seek to that offset, and then we're just going to read what's in that physical memory. So we map that physical memory into some buffer. We're going to scan that buffer for some known signature. Basically, that signature is going to be something that represents a known structure that we're aware of. In this case, it's going to be a process structure. The e-process structure is essentially what's used by kernel to represent processes. Every running userland process has an e-process structure. We use a D word to identify basically the beginning of the structure. We do a bunch of checks after that because relying on one D word in memory is ridiculous and will result in a lot of caveats and false positives. There's a talk I gave a couple years ago on process detection and how to sort of weed those out. So this is a slide we're actually going to spend some time on. Again, I'm sorry we're going to go so quickly here, but sort of have to. So we find all processes in physical memory. That's awesome. Very nice. Every e-process structure has something called the VAD root. VAD stands for Virtual Address Descriptor, and so it's a root. And so basically it's a pointer to a binary self-balancing tree. This binary self-balancing tree is what you would see in Computer Science 101. It's going to have left, right, child pointers, parent pointer. It's going to be very nice. It's actually, the binary tree contains what are called Memory Manager Virtual Address Descriptor entries, MMVAD entries. These entries describe the memory section that essentially that virtual address is represented. So within an entry, the entry is going to contain a virtual start address and a virtual size of each memory section utilized by Windows or by that process. Every MMVAD entry that contains some kind of mapped DLL or executable will actually have a pointer to the DLL or executable's path. So we can enumerate all loaded DLLs from this virtual address tree. The tree is used by Windows to manage the process virtual address space. Here's the structure itself through Windowbug's eyes. You've got your starting VPN, ending VPN, which are the starting virtual address and virtual size. It's so confusing having all the clapping. So OllyDebug has a memory map view, and this memory map view is very helpful in explaining to audiences what VADs look like. Basically, this memory map view shows you the VAD flattened out. So you can see it starts at hex 10,000, goes to hex 20, hex 30,000, and then there's space between hex 30,000 and hex 7B, whatever. That space is what Windows uses to represent essentially where it can allocate the next threads if it needs to. So it's very important that Windows is aware of what virtual sections can be used and which are available. By enumerating this tree, we have the ability to completely enumerate a process address space, which gives us all the processes heaps, all the processes stacks, binary images, things like that. It's also going to give us freed memory, which becomes important later on. So here's a cool graphic. You have your kernel addresses. They point to something. In this case, that D word is what we use to find an E process. We do some more checks. We mark it as an E process. We parse it as such. We dereference the virtual address root, and we get a tree. This is the tree as it looks. Basically, you have your starting, ending, and your left child and parent. We write each starting and ending virtual address to disk in its own file. So each entry in the tree represents its own file. This is probably horrible resolution. Yup. Basically, this is what the acquired address space looks like for a given process. In our demo coming up, we'll show you one that doesn't hurt your eyes. So process acquisition, we did this really quickly. It allows the dumping of the full address space. You're going to overcome most binary packing techniques because it's unpacked, and so it's running in memory. You can just acquire it very easily. You capture communication protocol strings. That's very important to recognize. We're going to talk about that coming up. It obviously bypasses anti-debugging techniques because it's not a debugger, so obviously that should work. And then you get unique things like DLLs that are only in memory, think Meterpreter. You also get things written to disk like the injected thread or the actual shellcode, the staged shellcode that Meterpreter sent into memory for the exploit. So you get a lot of really unique data that you wouldn't otherwise have. MetaSploit time.
All right, I'm not really going to go through this. I'm sure you guys know H.D. Moore, and he developed this, and it's all good, so we're going to skip all this. Yeah, I know, mind-blowing information. All right, so we're going to get into Meterpreter, and I'm sure you guys have been beat to death with this already today, but we're just going to get into some of the limitations that normal shell would give us if we want to pop a process. and then start to execute arbitrary code. So we're going to be limited to specific things like standard error, standard out. Those are going to be our handles that we're going to be limited to. Meterpreter is not going to have that specific feat because it provides the client-server Meterpreter implementation, which is going to give us client extensions, such as uploading and downloading, keylogging, and what have you, networking, which HD recently added. So these can all be completely memory resident unless a particular attacker wants to write something to disk or write more malware to disk, what have you. Another thing is Meterpreter scripts. These are very customizable. They can be created by anybody. I know we just saw Chris has a bunch. We have, I forget the guy's name now. Carlos has a bunch. So we're going to go into those a little bit, but they can use it to automate something an attacker would want to do on the fly. So let's say, for example, I want to enable terminal services on a specific person that I exploited, process I exploited, what have you. It's easily able to automate all that. So let's just skip all this for now. Also, let me get into a little bit of Meterpreter under the hood, which is going to be our injection method. So we have the old injection method, which developed by JR and Escape. So these are going to, excuse me, JT, I'm very sorry. So what this is going to do is allow us to basically inject some shellcode buffer that we have after we have exploited and load that into a specific process using a load library. And the way that's done is, I'm not going to get into it very much, but basically apply some userland hook to NT open section, NT create section, NT query attributes, NT open file, and NT map view of section. So what that's going to allow us to do is basically override the traditional method of load library, which particularly looks for some type of DLL that's going to be on disk or on some type of Samba share. The new method, which was recently added as a default injection method, which is going to be the reflective DLL. And this is basically a neat little new method which is going to use a mini PE loader, which is basically a shellcode stub at the beginning of the injected shellcode, which is basically going to walk down and load the environment and load the DLL and load where everything is ready to go. So what that's going to do is, number one, not have any handles to specific DLL. So metserve.dll, the old method, it would leave a specific open handle because the operating system or the host processor was actually aware of that all happening. This new method leaves no presence in the PEB. So we're going to be able to bypass that, and it's going to make it even more stealthy, coupled along with the OpenSSL implementation. And speaking of networking, we're now just going to dive into the networking aspect. Originally, packets were set in clear text. Recently, like I just said, they were going to be wrapped in OpenSSL, but the initial packet structure is going to remain the same. So even though we have this encrypted nature over the network, in memory, everything is exactly the same, and I'm going to get into why that's relevant in just a minute. So Meterpreter communication, it's going to use this TLV structure. For all intents and purposes, I'm going to continue to refer to it as TLV, but in actuality, it's LTV, and what that is actually a type length value field. 32 bits are used for the length and the type, and then n number of bits are used for the value. And also within that value, we can have nested TLVs, and that'll be more prevalent in the next few slides. So to lay this all out of everything I just said, we have a nice little diagram so you guys can see that. So the attacker is going to send the exploit just like we did before. They're going to use Meterpreter payload. We use bind TCP. I forgot to mention that. So the attacker is going to want to do something. In this case, we're going to do a get PID, which is just going to return the current process of the injected DLL. So the attacker is going to execute the get PID request. It's going to be sent to the Meterpreter server. That specific request is going to have this TLV packet. It's going to have a type length value. The type is going to be of the packet type request. There's going to be a length and then specifically a value. The value is the most important aspect of this entire packet because this is what we're going to be using in our tool, which we released later. We released at Black Hat, which is freely available for download. We have the link included in the slides. But just keep note that this standard API sys process get PID. So this is going to return an actual value that's going to be looked up in the Meterpreter function dispatcher table. So Meterpreter is aware of all this packet structure and everything, so it's going to parse all this out and then figure out what do I have to do? What does the attacker want me to actually execute? And in this case, it's just simply going to be get current process ID, which is no big deal. So Meterpreter looks up what it has to do in its function dispatch table. It's going to point to get process ID, execute that actual code of get current process ID. It's going to build a response on the heap. It's going to then send that response back to the attacker, and then it's going to free that packet from the heap. So as you can see, just laid out very quickly, this is basically the Meterpreter communication structure. And what we're going to do is go through and dive into a packet response. Now, I said that there's the request packet and the response packet. We're going to dive into response packet. Peter will get into some of the caveats dealing with a response packet versus a request packet and what our tool will actually parse out. But just going through, and as I said before, we're going to have those nested TLVs. This is going to be a specific one we just looked at in terms of response. So we basically have our length, which is going to be the size of the response packet, the type response packet. Now we have plain TLV type plain response. That's going to be changed. What's the new method? We can't recall the new method, but it's wrapped in OpenSSL, so they changed that specific parameter. And the value is then going to be nested TLVs. So we have our standard API sysprocess get PID, which is going to be the method. We then have the communication channel, which is going to be TLV type request ID. This specific value is used just from interpreter, server, and client to keep track of what data goes where when it's displaying it to the user and also sending it to interpreter. And also going to be the TLV type PID. This is going to be the actual response from the get current process ID. This is just a hexadecimal value. And finally, a TLV type result. This is going to be if there was any type of error, null, because we didn't have any specific error. And you can see how that all makes a nice little packet structure. Our tool, MSFF, which Peter's going to get into in just a minute, basically parses all of this out, and you'll see that during our demo. So I'm going to go through this really quickly. We just looked at it from a network perspective in memory. This is a VAD file which was dumped out from interpreter. So just like it looked like on the network, we can see this parsed out in memory. So we can see our standard API sys get process ID request. We're also going to have our TLV type request ID and the value. The type PID, which is going to be the result of get current process ID. And then the result, which is going to be null.
Real quick, yeah, we'll keep going here. All right, we're going to go to the actual framework because we have like 10 minutes, so we want to do that and then do the demo. Open source project written in Python. We haven't learned Ruby yet. We may do so, but it hasn't come to us yet. So here we are. It's pluggable to support rapid development from Metasploit modules, such as if HD wakes up one morning and decides to do something, we can respond pretty quickly. That was the idea. We'll talk about how come that's not going to matter after Sunday. So how does it work? Basically, it works like this. You acquire the process with Memorize. You then scan the acquired process looking for specific methods. These methods correlate to commands that the attacker executed. Basically, we'll then take those methods we find. Because we know the TLV is so well defined, we can pivot around those methods. We know what will come after the method. We know what will come before the method. So we can parse out what was sent back to the attacker or what was sent to the victim machine, depending on the method that we're actually looking to essentially reconstruct. So you're going to get things like the commands or results that were executed on the machine by the attacker. You may see like a registry key that the attacker modified. You may see the attacker did a hash dump. And you'll see these things come out in our demo. Here are all the supported commands. We tried to get everything in there. All the sniffer commands that HD added, PS, CD, you can see. The one I point out is injected DLL is not an actual command interpreter supports, but that will identify and name the injected DLLs. So it'll say metserv DLL, priv DLL, standard API, incognito, whatever the DLL is. So it'll pull the name out for you. We can tell you if they did a timestamp, migrate, execute, the execute command. If they executed a command shell and did a bunch of commands into the command shell, we can actually pull those commands out and show you what was displayed back. So we didn't talk about scripts. I'm going to go over it real quick. When an interpreter script runs, it actually makes method requests. Those method requests correlate to commands that interpreter understands. If you pull those, if you execute those commands defined in memory and we find them, you can sort of get an idea of what scripts were executed. So here's get GUI. Here's kill AV. It works pretty well if you see a process listing and then you see nav and process explorer and things like that disappear. You have a pretty good idea what happened. All right, real quick, just so you guys know, this tool, it relies on basically freed memory. So MetaInterpreter receives a packet. That packet is freed. The Windows Memory Manager doesn't scrub the memory. So when that memory is freed, it sits there. And those packets just sit there, and they're just asking to be used. So basically, we utilize that in this demo, in this attack, if you will, to reconstruct what happens with Meterpreter. HD was kind enough, after he saw our abstract, not to patch it before. He will patch it on Sunday, he said. He's also going to zero out the MZPE header to make Meterpreter more stealthy. We will update the tool to identify injected interpreter binaries because we can. There are many different ways we may do this, just so you know there's not just one way. There's a dispatch table in Meterpreter that has all the methods that Meterpreter receives. That's signaturable and pretty identifiable, and will also allow us to signature which DLL is loaded. The import table in some cases can't be zeroed out. We can utilize the import table to determine what's going on. Bottom line is, at this point, Meterpreter has too much code in memory to be stealthy for memory analysis. It's going to be very stealthy over the wire. It's going to be very stealthy on the system for disk forensics. Using memory analysis right now, we feel pretty confident. Notice I put currently in there. Please note that. Someone's going to come up with some good idea and break us really bad, I have a feeling. So, but currently, I feel comfortable saying that. So, here we are. Caveats and gotchas. Acquired exploited process does not always yield 100% result. Basically, you're going to get partial results. Memory is volatile. This tool depends on what's going on in the system. We've seen full sessions stay in memory 4 hours with heavy system use. We've seen them disappear after 3 minutes with heavy system use. It depends. What we can say is you will get something, whether it's a migrate command, maybe it's a hash dump. You're going to get something that's going to alert you, that give you some idea of what the attacker did. For example, if you see migrate to explorer.exe, but you don't see them start a keylogger, no one really migrates to explorer.exe for any other reason except that they may want to start a keylogger. So you can infer these things. So it'll take some extrapolation. Basic conclusion. The Windows Memory Manager gives the memory forensic analyst a real good chance to see artifact memory. There's really nothing taking this view of scrubbing memory correctly. We believe it has a pretty large impact for memory forensics. This is just the first tool of its kind. We hope that it'll spawn many more. It has no impact on the MetaSploit project whatsoever. There were some articles released saying researchers hacked Metasploit. We did no such thing. We just wrote this tool. Metasploit, as I said, is going to patch this and further make themselves stealthy. So defense leads to offense, which will lead to defense. We recognize this is a cat and mouse game, and we're just happy to play. So we just hope this research project will lead to more fun stuff. All right, here we go. So please recall that we popped the machine. I'm going to go to my memorized directory. 198, right? 1080. We ran a bunch of processes. But it's not 1080. All right, we're going to acquire process 1080. I'm also going to verify that that was the actual process we exploited, just because we didn't write it down. Oh, it should be 1080 actually. So memorize is running. What you see here is output. It's determined dynamically the major version and the minor version. No API calls made. Yeah, we're good. Just so you guys can see what the actual install directory of Memorize looks like. This is what it looks like. All output is written to the audits directory. And you have your batch scripts to help run the actual tool, because people are scared of editing XML apparently, which was unbeknownst to us at the time that we wrote this tool. So here's the actual acquired address space. I'm going to put this in a list so you guys can see it. We've got DLLs. You've got your .vad files are your memory sections, so they're just unnamed. It's still writing stuff to disk because this is a pretty big address space here. So it's still going. It's chugging along here. It's essentially it enumerated all processes in physical memory. It's writing it to disk. Those are just warnings. Don't worry about them. That's the truth. All right, we're going to go to our actual tool. So again, really you'd think adding a -all command is pretty straightforward. We didn't think of that until like the night before. So that's why it's last there, and it makes the most sense to have a -all command. So we're going to use that command that we just thought of adding on this example. And 2 fingers. All right, here we go. Demo gods, come on.
You didn't do dash.
Oh, I got to specify what I want to do. Yeah, it did. Yeah, that was not a bug. I just want to point out. Oh, what do you know? Today's a good day. All right. Whoa. Where are we? Okay. So here's where the command was executed. Successfully executed, I should say. Right here. It's identified met served.dll. Here's actually where the attacker executed the command shell. It's telling you what the process was. It would substitute that with anything. It just happened to be command, obviously. Here's where the command shell prompt was sent back to the attacker. That's pretty nice to see. You get a second little part of that. Standard API DLL was found. Priv DLL was found. Don't see the net. Here's where the attacker executed, or the results of the net user command. Here's where the attacker executed net stop themes. Because memory is not linear in the sense that your allocations will be at lower ranges depending on time. Basically, you should get most of this, but it may be in a different order. Here's where where net themes was stopped successfully. That was sent back to the attacker, if you recall. Here are hashes. That's pretty good to know, especially if this were a domain controller. It would be a lot longer and a lot more deadly. Here's our process listing. So we can see the attacker did a process listing. And here's the summary of essentially what was found when. We have another demo. We're not going to do it because we want everyone to get a chance to see all the other great talks on this track, but it's not just remote attacks. We can do it on browsers. We can do it on other things. All of our slides are online. This tool is also online at mandiant.com, so you can just grab it. It's open source, freely available. If you have a question, either grab us or shout it out now while we start moving ourselves off stage for the next person. Thank you, guys.
And Peter learned how to use a Mac for this talk, so big round of applause.
Yeah. Thank you. It was not as easy as you would think.
All right.
Calling either Dino, David Maynor, who else? Whoever wants up next.
Rock, paper, scissors.
Who's coming? Okay, all right. Sorry we cut you. I didn't, we're going through this now because the online schedule's wrong.
No problem at all.
You get all your shit?
Yeah.
All right.
Hi, my name is Dave Maynard. I'm going to go in a second when I get my laptop set up.
All right, so like I said, my name is Dave Maynor. I am from a company called Errata Security, and I am an unabashed MetaSploit fan, which is why I'm here. If you're wondering what the large British gentleman and the short red head have to do with MetaSploit, the answer is nothing. But considering that this talk was originally scheduled, well, it was supposed to be 70 minutes, and then it got, due to things, it got cut down to half an hour, I had to cut out a lot of stuff. So I figured, to be fair to you, I should buy lots of people beer. So if you go over to those people and show them your ID, they will give you free beer. Well, that's a great response. Thank you. So let's get enthusiastic, people. We're talking about Metasploit here, and Metasploit is the coolest thing to ever happen to exploitation technology, period. And the best part is it's free. So like I said, my name's Dave Maynard, and I'm going to talk about application assessments. So Metasploit, if you don't know what it is, I'm pretty sure you're in the wrong track. I'm not wearing a Team of JJ shirt, so where are you supposed to be? Before I continue, I want to thank H.C. Moore. I'm sure, being a Metasploit track, he's been thanked 400 times today, but I got to thank him again. And also to Val Smith, who made this track possible. If you saw the behind-the-scenes communication Val Smith had with everybody about hurting the cats involved to make something like this happen, you'd feel sad for him. So I'd like to start off by saying that I don't know if you know this or not, but every time you run the Metasploit console, you get a different banner, and the cow is my favorite banner. So breaking in, that's what everybody thinks about Metasploit, right? Metasploit's used for penetration testing. I do pen tests. I use Metasploit all the time. And I use Metasploit all the time because it has high-quality exploits, great payloads, and MetaTrepidar is pretty freaking awesome. I do exploit development. Metasploit is my framework of choice because of ICE. Because it has tons of functionality built in. And, if I were HTML... Hey, that's my MacBook. Come on. Steve Jobs would be very sad about this. There's water in there. Wait, I got to wipe this off before I... So, if I were H.C. Moore, I'd be very happy about the fact that everybody wants to rip off my shellcode to use in their exploits to go up on Mailworm. And there's also lots of other tools that make writing exploits possible, like opcode, the opcode database, pscan, lots of other stuff. I also do application assessments, and this is where it gets interesting. And a lot of people are always curious when I go on site, and I'm like, yes, I'm doing an application assessment. Like, oh, what are you going to use? Are you going to use something like a Web Inspect, or are you going to use NTL Spider? I'm like, no, I'm going to use Metasploit. And they're always surprised by that. So what Metasploit does for you while you're doing an application assessment, it can do everything for you. So if you're familiar with Metasploit, the next few slides might be boring. Feel free to Twitter, check your email. But if you're new to the exploit, have you ever wondered why Metasploit makes those high-quality, reliable exploits? It's not fairies. It's Rex. So if you're just a user of Metasploit, you've never actually dug around inside it, look in lib Rex, and you'll find a whole lot of code for a whole lot of different stuff. And it's very the entire point of this talk, if you want to go see another talk and leave now, I'll cut to the chase. The entire point of this talk is that you can repurpose Rex code to do almost anything for an application assessment or vuln dev assignment that would generally take developing a lot or writing a lot of different code that can be done easily in Metasploit. Rex is where most of the functions Metasploit exploit stuff uses. I have a screenshot of what I did in find space dot pipe more. So I came from a company called Internet Security Systems. It's unfortunately no more. They were purchased by IBM and they were absorbed back into a blob. But when I was there, I wrote one of my jobs was to test the IPS against all kinds of different exploits. And one of the things I loved about Metasploit is it was easy to write new versions of any exploit they had to evade almost any security tool. One of the great things they have about it, and it's really full features, is DC RPC handling stuff. They also have lots of other protocols like HTTP, various things. So here's a quick story. Have you ever heard a joke about golf? Golf was a nice walk ruined by a little white ball. In hindsight, I guess nobody here really plays golf. Never mind. So app assessments are the same way. I used to love my job before I had to write statements of work. Right. A lot of the statement of works have to be written from the point of view that you have to deliver a service. You have to do it with a certain amount of tools, things like that. But a lot of the tools that you'd want to use for an application assessment cost a lot of money. Maintaining yearly licenses for these tools is cost prohibitive. So generally, if you want to use them, you have to license them for a specific gig, which means you have to pass the cost on to your customer, which means they don't want to do that. Or I've run into lots of situations where people will only let tools on a certain list be used in their environment. And luckily, MetaSploit is on every list I've ever seen like this. So how do you do the same work with lists? Oftentimes, like I said, I'll get information dumped on me at the last minute that requires something special. So I'm going to show you 3 quick examples, so Dino can go, but the quick examples all around, revolve around using MetaSploit to do an application assessment or something that would have generally taken you a whole lot of time that you could probably do in less than 5 or 10 minutes. But the biggest thing about these examples isn't the examples themselves, but I want to show how easy it is to actually use MetaSploit or use the source tree to go through, and it's easy once you read examples to figure out how to do additional stuff, like to extend exploits, things like that. So the first one is like a web app proxy, and like everybody has web app proxies, right? Like Peros, things like that. This is just an example. So you got a web app, I was actually on a gig once where Web Inspect and NTO were both blowing up. And they couldn't scan a site due to CA's AppMinder. So I wrote a quick script in MetaSploit that would basically proxy all the Web Inspect requests and rewrite them as necessary. So if you were to actually look through it, one of the first exploits that I really studied on how it was written in MetaSploit was the WMF bug. And if you take a look at the code for the WMF bug, originally when file format vulnerabilities and stuff like that are released, a lot of people will ask me, how does MetaSploit do that? What do you do? Do you generate a file and you email it to people? I know generally, like for WMF, for instance, it will actually run a web server, and when you connect to that web server, it will send you bad content. So if you take a look at that, it's pretty easy to repurpose that code to take a web server, listen on a port, take that request, rewrite it, and send it to your victim. In fact, I did that in about 20 minutes on a site once because, like I said, after 2 hours of trying to get a commercial scanner to do what I want, it was easier to make MetaSploit do it in, I guess it was less than 100 lines of code. And it's Ruby code, so a lot of the lines are like, params and stuff, but, they still count. The best part of the code about this, especially when you're doing application assessments, is this is code you can leave behind with your client or something like that. Generally, like if you're using a specific or commercial tool or something like that, and you produce results, you can show them the results, but you can't really leave them the tool behind to use for further testing because, it's commercial licenses, things like that. MetaSploit scripts that you write for clients like this, you can leave behind, and it's great. Everybody wins. So example 2 is the AS400. I've just recently got done doing an AS400 research project, which we did a comprehensive audit of AS400 stuff. And MetaSploit was instrumental in all of that because there's lots of problems everywhere. But it's basically so if you were to go onto a client site and they have a new protocol or something like that, or like for instance, if you were working for an embedded device manufacturer and the embedded device manufacturer has a new router and the router has port 23 open, you could you could run one of the other fuzzers. I wrote one in MetaSploit in 3 easy steps. So I have a template, and I'm actually going to make that available. The longer talk this was all based on will be available on our website, and I'll send it to HD as well. But I have a template that's just basically a blank exploit that you can use for everything. You said R port to 23, and I wrote a simple fuzzer loop that found bugs in the AS400 telnet server. And you might be asking yourself, where would you find an example of a simple fuzzer loop? Well, HD Moore actually wrote one. So one of the things that if I'm ever stuck on a project and I can't find something to do, I find space dot pipe xrs grep-i for whatever I'm looking for. And generally in the MetaSploit tree you might find something that could help you. For instance, in this case, I grep-i for fuzz. And down there at the bottom you might see the modules auxiliary DOS fuzz. Right. So if you don't remember the wireless fiasco a couple years ago, these were all written during that. But I always use them when I'm talking to people about MetaSploit as examples of how to write quick and dirty fuzzers that produce great results. So for instance, this is a create frame function from it. You can create a function similar to this, and most of the fuzzers I write look very similar to this to test, like for instance, the telnet sub options, environment settings, and things like that in telnet. It would take you literally 5 minutes, and the best thing about debugging it is you don't have to wait for a new build every time, right? So those were examples of quick and dirty. So the thing I love about MetaSploit the most is when you're doing application assessments and things like that, It's just not always on a standard website. You might have to run it on an odd you might have to do an application assessment on an odd platform or something like that, and you might not have tools that you're used to. Metasploit's there for you always. For instance, this is Metasploit with the cow on N800 from a couple of years ago. But recently I wrote a blog post on iPhone SMS hacking. I'm sure everybody heard about the Charlie Miller thing, the SMS hacking. So I decided to write a blog post about that, where I take the information that I find from the media and try to duplicate that. Metasploit was instrumental in doing that. As you can see here, this is actually Metasploit running on my iPhone. But one of the great things about this was that I was able to unwrap this. I was able to take Metasploit and put it on iPhone, and using the same development methodology I use for everything else, I was able to knock out SMS messages that get populated in SMSDB in less than 10 minutes. So whereas you might walk into an application assessment somewhere and you might need some ramp up time, when you're used to doing a lot of this stuff in Metasploit, like platform independence is important because there really is no ramp up time. It's the same interface that you're used to. So incidentally, look for an update to that blog post this week about bugs that were not fixed in the iPhone 3.0.1. We were trying to have that done for this talk, but because everything's going short, yeah. So that's actually my talk. I tried to get it done really fast. Does anybody have any questions? Right. Well, I actually did that in 10 minutes. I should have drugged this out some. Any questions, comments, suggestions? Does everybody want to start an HD More 11 circle right now? Those guys do, apparently. Cool. Well, thank you very much for listening. And I'm sorry if I sounded like that guy from the Micro Machine commercials. But, things were cut short. Thank you very much. Yes, sir. There is a question. Well, there's ways to do that, but to build a cleaner API, we actually have one. We want to contribute to Metasploit for that very reason. So one of the things actually about fuzzing, I actually also, this is a strange thing since we're talking about application assessments, I keep two directories, an MS current directory and an MS devil directory, because I screw up the MS devil directory all the time, and with code I write and stuff like that, and the MS current is a pretty good working copy. So one of the useful things about fuzzing, as you were asking, is where is it? Like if you look at the wireless example here, it's bad when a single product like Wireshark has its own directory in Metasploit. So if you look at stuff like fuzzbeacon, the rex text.rantext. So there's a whole bunch of different ways that Metasploit, and if you read the Rex documentation, I should have had one in this slide deck, but actually I strangely don't. There's a lot of different ways to generate padded information that makes like fuzzing more useful. So for instance, with the Firefox font tag exploit that came out a couple weeks ago, I wrote a version of that works on OS X. And one of the reasons I was able to do it so quickly is I took the exploit that was on Millworm, ported it to Metasploit, and then used their text padding stuff to actually find out where I was crashing in the heap spray stuff. And that's always useful. I don't know if that answers your question or not. I don't know even that was really your question. I just felt like going off on a tangent. Right. Any other questions? Well, so like I said, everybody should read the Rex documentation. Especially if you're doing things like this, you would be amazed at what you can do in Metasploit in a couple lines of code that somebody would think that would take a developer a week to do, or a good exploit writer. Yes, sir. Yeah. We're actually publishing a resource report on that in upcoming weeks. We're licensing the security content we developed to various content IPS and scanner vendors right now. But there's a version of this being released to the public. Any other questions? So while I'm here, I'm going to tell you a funny story about IBM and the AS400. Using Metasploit, like I said, I found lots of bugs. And if you ever have seen a default install of AS400s, there's a ton of open ports, like 23, 110, LPD. I can't remember the port number off the top of my head. You know, all these things are open by default. So we started finding bugs, and we decided that, you know, we're going to try to responsibly disclose these to the vendor. So I call IBM. I call the support people, or the people who are supposed to be in charge of security, and I sent. They tell me to send an email to this email address. I send an email, and I tell them that we have bugs that would allow me to break into a telnet server on an AS400 with no problem. I could log in as like QSECFOR, and if you don't know what that is, that's kind of like root. Oh, it's like the security officer for an AS400. And they said to me, and I'm serious, that they needed a maintenance contract number to accept any bugs. And I was like, well, I bought these things on eBay. I don't really have a maintenance contract number. And they were like, call back when you do have a maintenance contract number. So that was great. I should have submitted that one for the Pony Awards, but I didn't. Any other questions, comments? Cool. Thank you very much. Is all the beer gone? Wow. So Dino's up next if he's... Oh, yeah, there you are. I try to talk as fast as possible.
I was like, quick. I was going to go ahead and 20 minutes if you wanted to dance or something.
Are you serving me a warrant or something? Don't think. I think Dino would be a better person on the record badge than me. I don't know. You can sign. Yeah. Do you have a pen or a Sharpie or something? Will this work? No, it won't. Oh crap! I left all this stuff here. I'm sorry, I had to pull a whole bunch of crap out to find my folder. You got your clipboard there?
Yeah, I got that. Power. Make sure it's visible. Okay. All right. Well, we're 20 minutes early, so may as well start anyway. Thank you. Thank you. Just show of hands here. How many of you have popped a Windows box with Metasploit in your lives? All right, it's pretty good. How many of you have ever popped a Linux box with Metasploit?
All right. How many of you have popped a Mac with MetaSploit? That's 2, 3, 4. Okay. So I want to change that. That's the goal of this entire talk. Not because I hate Macs. I love Macs. And I just want to see them have equal standing. Isn't that what we all want? Equality? So why think about Maxploitation? And why use Metasploit for it? Main reason is Macs are gaining more market share for consumers and business. And as penetration testers, your job was to demonstrate risk to your clients. And if they have a bunch of Macs, they may be under the impression that they have no security risk for them, and they don't need to do things like patch management or anything like that. And so if you have some nice exploits, some Metasploit, some interpreter goodness, you can show them how it's done. And as we all here know, Macs can be compromised like anything else, and it'll probably take roughly 3,000 pwn-to-own contests before the average Mac user actually believes it. And one of our goals is we want to make the tools available in Metasploit, just make Mac a kind of a first-class citizen or a first-class target. And so we're going to talk about some of the tools that Charlie and I wrote for our book, the Mac Hacker's Handbook. And most of it has been contributed to Metasploit. The stuff that's in there right now is my bundle injection stuff, which is like DLL injection for Windows, but this is what basically injects bundles, which are sort of a low-level, like DLLs for OS X. And I have the Charlie's interpreter stuff on my hard drive, where it is sat for about 4 months. And because basically HD's been really busy, and I just didn't want to add to his workload, so I thought I'd be a nice guy and just hoard it for a while. But actually, now that JR has ported interpreter to POSIX, it's going to make it much easier for us just to take the 5 lines that are actually different and then add those in. So the first thing we need is for the bundle injection, we need the Mako function resolver. This is what you use to actually resolve function names, because it's great to be able to execute system calls, but you want to do high-level functionality. You need to be able to dynamically resolve these at runtime. This is made very easy on the Mac platform because the dynamic linker called DYLD is always at the constant address, and it begins with the same structure, the mock header structure, and you can just basically parse through that table, and it's actually a pretty good format. It's really, PE is very complicated because you have basically 3 or 4 generations of linkers that are basically carried into the same format. Mako is much cleaner, very easy to parse. Assembly code's very easy. And all we need to do is basically parse through the structure, find what's called the symbol table, and then do the familiar ROR13 hash, which is the technique that LSD originally used, although theirs was a ROL7. And now all the Metasploit payloads do a ROR13. The same idea was done by Nemo in his frac paper, OSX Wars and X New Hope, which was basically Nemo going around everywhere he could and taking all the good ideas before anyone else could get to them. He's like, kernel rootkits, check, I can do that. Dynamic symbol resolution, check, I can do that. If you're not familiar with a lot of Nemo's frac work, you actually really need to check it out because he does some great stuff. So how does the bundle injection work? Bundle injection is a multi-stage process where the first stage is what I call the remote execution loop. And this is just think of it as a machine code interpreter. It reads data over the socket, throws it in memory, and then executes it as machine code, and then repeats. And what it does is sort of treats it as a function, so that basically you can get a result, and it will send it back as well. On top of that, we build a second stage, which is the inject bundle stage. And what this will do is this will read a bundle over the socket and load it into memory, and then actually link it and load it. So on Windows, with the old DLL injection method, it required actually patching, as I think in your talk, JR mentioned, required patching a lot of the APIs in memory to sort of trick Windows into thinking that it was loading a file when it was actually just reading a piece of memory. However, in OS X, the linker actually provides functions to do this for us. There are 2 functions, one called NSCreateObjectFileImage from memory, which is quite a mouthful, and NSLink module. And basically what these do is these respectively load and link a module for you. Just basically point it to some memory that is the actual file from disk, just crammed into memory, and it'll unpack it, placing the memory segments where they need to be, and then NSLink module will actually load up any dependent libraries, link them in. And what this means is that the third stage, which is just an arbitrary compiled bundle, can use any framework on the system. And you can write it in C, C++, Objective-C, and that means you can use everything from QuickTime to their wireless frameworks to anything. And it's a very great way to do things. And I'll show you kind of a skeleton code that you can use to actually write your own. Actually, I kind of already gave a lot of this detail, so there's no real reason to call it again. So basically, here's the code, if anyone can see that, to a injectable bundle. All it is a set of 3 functions, init and fini, and basically init and fini are declared as respectively the constructor and the destructor. And so those are called implicitly by the linker when it's loaded and implicitly by the linker when the module is unloaded. And then you have a run function, which takes the socket, and this is actually called explicitly, and this is where the bundle does its thing, whatever that might be. And so the first thing that I thought of when I wrote this was, so what would be an interesting thing to do that would use some of the unique capabilities of Mac OS X and Apple hardware? And what I did is I wrote what's called the iSight Capture Bundle, or what's kind of been truncated, what I call take a pic of the VIC. And this shows just basically pretty much how easy it is to do. QuickTime makes, it's a high-level API, and they have a sequence grabber, and you can they actually have example code on Apple's website on how to do this, and it was wrapped up into a package called Cocoa Sequence Grabber. So basically all I do is I just include that code, use it, and all of a sudden we are grabbing pictures. Perhaps a more familiar thing to do would be to load Meterpreter. So I'm not going to subject everyone to another description of what Meterpreter is. I'll assume that we all are familiar with that at this point. And boom, you can use Meterpreter to pivot through hosts, hack through there. And basically, one of the key things to think about with Meterpreter is that you have 2 components. You have the server side, like binary code libraries that are loaded, and you also have client-side modules that actually interact with that. So there's kind of 2 halves to it. And so what Charlie and I did is we wrote what we called MacTerpreter, which is just a port of the Meterpreter to Mac OS X, uses the inject bundle payload, and uses the DYLD functions, create object file from memory, and link module to make sure that none of the either the Meterpreter itself or any of the libraries that it loads ever touch the disk. So it's actually binary. It's pretty compatible with the Windows Meterpreter. Shares most of its source, and just kind of if-deffed out stuff that doesn't make sense, and replaced it with Mac implementations. There are some limitations of what the Meterpreter can do on Mac. One of the most glaring and most annoying is you can't do process migration. This is kind of one of the cooler features of Meterpreter, but the way that the Mac operating system works is, whereas on Unix and Windows you can, if you own a process, meaning if you're executing the same user as that process, on all these systems, you can actually open its memory and debug it and read and write memory as needed. And this is basically how Meterpreter works on these, process migration works on these platforms. However, on Mac OS X, which is based on Mach, you actually need access to what's called the Mach task port. And this is fairly highly protected. And the default security policy is that you can only access the Mach port of other tasks if you are root. Or if you are a member, if your process is running as a group of a member called proc mod, which is basically just the debugger. So on a stock system that doesn't have the developer tools, there's really nothing, you can't attach to any other processes, either other processes that you own. You can do it for a child process, but that's about it. So you could use the process migration only as like a fork, basically. So you can run your Meterpreter in a child process and let the parent process either continue executing if you have continuation of execution stubs in your exploits to actually keep it doing that, or just let it crash. And so then if the application has crashed, you can keep doing stuff in the background. Some things aren't actually implemented. This slide is from Charlie, so when it says I think Charlie. I got lazy for completely different other things. And basically we're going to be trying to add a lot of this stuff to MetaSploit. And let's actually do this. I'm going to go back to the demo after this slide just so I can kind of play around in there to fill some time.
Some of the stuff that's already in Metasploit right now, we're going to add more of, is a number of exploits from the Mac Hacker's Handbook. So the first one is actually a really great one that kind of slipped under the radar. For many versions of Tiger, for probably most of the time that it was out, there was a default out-of-the-box remote route that went through the firewall. So even if you took every GUI option, turned on the firewall, allowed strict filtering, turned on stealth mode, turned on logging, all this stuff, you still had a remote route through MDNS responder. It listened on a high UDP port, and the attacker could just scan for that and wait for a callback. And it was actually a great, really fun exploit. So basically, we're going to contribute the code for that. There's the QuickTime RTSP content type overflow. This is a simple stack overflow that actually makes a great exploit for demonstration because it's well behaved, relatively simple. And then the two respective exploits that Charlie and I used, or I used to win Pwn to Own the first year, and Charlie used to win Pwn to Own the second year, and all these payloads and stuff. So let's actually go to the bling. All right. All right. All right. Can we see this? All right. Okay, so what we're going to use is we're going to use the QuickTime RTSP exploit. So let's just, this exploit is a vulnerability in handling the content type header in an RTSP response. And while this could be embedded in a web page, the exploit I wrote right now just supports the standalone QuickTime player, but it's basically just a matter of changing offsets. It's not actually, anything tough. So yeah, I have to be a little patient. VMware or OS 10 in VMware is kind of flaky sometimes, but let's bring this up too. So I've got the familiar Metasploit console up here. Set the variables, get the exploit running. And first I'm just going to demo just simple shell payload, make sure all that works. So it just, that player stalls, and go back to this. So we have our, this is maybe a little difficult here. All right, and we have our command shell already running. All right, let's. Okay, so you can see we have our shell. It's very happy. One thing to keep in mind is for a lot of applications, there's two different sets of shells for OS 10 in Metasploit. There's kind of the normal shells, and there's another one called the vfork shells. If your application that you're exploiting is actually multi-threaded, this includes just about anything of interest. You'll want to use the vfork shells because those will actually work. The normal ones will only work on single-threaded applications. So we're in a shell. We can do sort of whatever we want. So we can do the fun things. Oh, all right. I tried to fly without a net. Apparently, the sound on VMware isn't working. But so basically, some of my couple favorite things to do on like pen tests for Macs is Say is fun. The other one is SBIN screen capture. Oh, looks like Say has actually frozen it. Okay, well, so basically capture screen is another thing you want to do. You just capture the screen, looks great in reports, so on. But let's actually play with Meterpreter now. All right, so this time I just relaunched MetaSploit with the Meterpreter payload, and let's just do the same thing here. All right, so we got Meterpreter open. You know, works nicely. We can do the same things that we can, you know, through a shell without, you know, actually launching a obvious shell on the remote system. If you look at the commands here, there's a new one in there. So this is a command called takepick. Doesn't actually exist on the other platforms. Let's just try it out and see what happens. It actually failed for my Black Hat demo. So I'm going to knock on wood. Let's see what it does. All right. Oh, the green light turned off. Oh, nope, it's hanging. All right, great. Basically, there seems to be, in VMware, there's some, like, the device actually opening up. In order to make it fast, I didn't want, like, whenever you access the iSight camera, the little green light loads. And so you want to leave it on just long enough to actually capture one frame. Oh, wait, it finished. Oh, let's see what happens here. Okay, so it actually, what the payload does, it drops a file called temp isight.jpg. You got it? Okay. All right. Let's make sure you can see that. All right. There we go. Thanks. And that's about all I have. So, anyone has any questions? I see one over there. The question was, is that vulnerability still present in the current release of QuickTime? The answer is no. There are actually no vulnerabilities in the current release of QuickTime. That is the official party line. That's what I've been told to say by Steve, and whatever Steve says, I do. So, any other? Okay, I see one back there. Does that work in blank blank blank? Yes, it will. Yeah, vFork shell works everywhere. vFork shell is nice. I just didn't want to kick out Ramon's shell without asking his permission. Any other questions? I just didn't want to. It was already there, just for kicks. Well, basically, so the old shell didn't work in multi-threaded applications. So I wrote basically a new shell payload, a new shell stage that actually worked in single-threaded and multi-threaded. But I don't really code well with others, and so I just did it from the beginning. And I didn't want to kick someone else's code out, so I kept it separate. Maybe eventually they'll be merged in, so it'll just work, which is a little more convenient. So the simple example, well, is vfork shell will work everywhere. But the real cause is basically you need to execute the vfork system call in a threaded application before you can fork. So any application, just about any application that's multi-threaded, so client software is most often multi-threaded. Network daemons, they will commonly be single-threaded, but you'll never find a single-threaded user like a desktop application. And if you want more detail on the vfork thing, read HD's PowerPC OSX tricks paper, and he kind of talks about why you need it in more detail. All right, is there any more? All right, cool. Well, thank you very much. Yeah, well, it's
Yeah, I know. So what happened with V4? Because I added V4 code into it. I had problems with it not working in the single thread app, and then Ramon replaced it all, and then he broke a piece that pulled all my code back out. So it's been
so there's some trick. I'll show you the source that I did for my vfork. Basically, I had to be a little tricky to make it work in a single threaded app.
okay because I couldn't figure it out.
It was like,
That's why there's originally.
okay, yeah, it was like, there was basically the problem.
Let me do a quick announcement real quick so people.
Oh, yeah, go ahead. Yeah, sure.
So because we are so aggressive in managing our time, we're now early. So there's now a Warvox presentation. So surprise, it comes with a free vodka. So if you can line up, and we'll start pouring shots, and then we'll start doing Warvox telephony stuff. This lovely woman's going to check our IDs, so I don't get it to go to jail. Hopefully. There's not too much vodka. We'll see what we can do.
That's right, because you weren't there when I visited Houston. Like I did a security training.
What's up, man?
And the Two Sigma thing was like a little bit of a detour. We didn't do penetration testing, security research, stuff like that. And so try something different for a while.
So we have another surprise talk. So after Warvox, Egypt's going to do something. Sorry. After the Warvox talk, Egypt's going to talk about the PHP Meterpreter, supporting all of Meterpreter to PHP. Yeah, just plug it in. If you want vodka, you can use it. This is your laptop then. Alrighty. Has anyone here actually used Warvox? Woohoo! Holy crap, there's actually users. This thing is just, written in out of the blue one day for fun, and I'm surprised people actually use it. Cool. All right. Well, I'm going to go ahead and get started. For folks who have seen some of the materials before, this may be a duplicate, but there's a bunch of new stuff then, including some live demos of Moscow, Beijing, some other fun places. So, first off, my name is H.T. Moore. I'm project lead for MetaSploit, yada, yada, yada. So way back when you used to break into boxes, you had to use modems to do it. It was really annoying. It took forever. Everything was protected by a modem. Everything that you got into via modem is protected by a password. There are very simple authentication tricks. Besides like dial backs and maybe some hardware tokens, there are very few things that you really had to do on top of just dialing into a system to get access. Back then, you used to find all sorts of really cool things. You'd find Unix boxes, remote access servers, PPP slip stuff, routers, switches, all sorts of cool data services here and there. What you still find today is that most of Unix, most of the routers, most of the switches no longer have direct dials, but a lot of the HVAC, SCADA, power management, radio gear has never gone off of dial-up. So these days, you only find the really interesting things when you start dialing. So anyone here who's used ToneLoc, the default map that it shows you when it shows you a call map is 100 by 100 numbers. So it's basically dialing an entire 10,000 number exchange. So it basically picks a different color for each grid of that 100 by 100 exchange to indicate what type of call it was. So each vertical row is sequential numbers, starts off at 0000 in the top left and 9999 in the bottom right. So the way that you classify these things was via, carrier, busy, voice, fax, timeout, but it also had the ability to manual classification. So while you're dialing, if you heard someone that sounded like they're hot, you could click the, oh yeah, hot chick button. And if there's some yelling asshole, there's the yelling asshole button. So it's great because you can actually map out particular people's voices and, oh, I know this person's this type of person. So that was cool, but there's no way to automatically do that. So I got started, sorry, let me go back. So I got started with this whole word dialing thing again when Druid started doing his telephony stuff, and I kind of got all OCD on it and just dove into it and stopped caring about word dialing and started caring more about voice stuff, and it was fun. But that's kind of the start, was all of Warvox work, all of Druid's work got me started on Warvox. So the general ToneLoc maps could look something like this. So each one of these squares and colors represents a type of number. Whether we dialed it, there's nothing there. Whether there's a tone, whether there's a carrier, girl, asshole, fax, VNB, whatever it happened to be. Each of those little yellow dots on the screen up here corresponds to a carrier. So you can see this is a probably residential network just based on the number of carriers and how things are scattered out there. Busy are reds, and I think faxes are purple, but it's hard to tell the colors on the screen here. Here's a much denser network. This is probably a corporate network, a corporate phone range or some industrial park somewhere. But you can see there's a whole lot more yellow. So tons and tons of dial-ups. These are all from way back in 1993, 1994. So just going to keep this stuff in mind when we start going forward. So word dialing today is you're still looking for modems, faxes, and tones. It's still really effective against really large orgs that have all kinds of crazy gear out there that you don't really see that much anymore. You still find HVAC systems that take dial-ins. All of Kmart's power for a while was managed through dial-ups from way back when, and who knows what stores or switch ones haven't still. So basically, the whole process is you start dialing a range, and you keep dialing until you find stuff, and you get a carrier, you log it. When you don't, you log it, and so on. But this is really slow and inefficient because you have to basically have one modem, one phone line, and 60 seconds plus for each call that you dial, because that's how long it takes for the modems to negotiate data. So it was a really, really slow process of going through 10,000 numbers because you have to basically spend 60 seconds per number. So 10,000 minutes to dial an exchange, about a week or so. And there is commercial software out there for this, but the only really usable commercial software is really expensive and still requires all this hardware investment to get running. So if you look at Sandstorm's Phone Sweep, which is still kind of the premier word dialing tool out there, the really basic version of the software with one modem, support of one modem not included, can do 60 calls an hour, but it takes about 1 minute per call. Starts at about $1,200. So not cheap for software. If you want the Phone Sweep Plus, it supports up to 16 modems and can do up to 1,000 calls per hour, which is a lot, and used to be. That costs you $35,000, or $35,600 plus support, plus tax, plus whatever else. I'm sure they'll give you a discount, but it's still more expensive than free. Secure Logics has something called Telesweep, which they'll give you if you fill in enough sales forms on their website, and that's handy. For the folks who just walked in, you already missed the vodka, so you can blame everyone else over here for drinking it better than you, or at least faster than you. So open source tools. For MS-DOS, you got ToneLoc, THCScan. On Unix systems, you have iWar, which is probably the best one out there. Pause, which is Python-based. All the MetaSploit stuff that Druid's been doing works great as a war dialer. And there's a couple other ones out there like ShockDial from Matt and WarD, things like that. If you want to start war dialing over voice over IP, there's a few options. Basically, you still need a modem, but now you also need a converter from voice over IP to modem to be able to use basically an analog telephone adapter to be able to make your calls. So this is annoying because it costs money for your adapter, now it costs money for your modem, and you're still limited to those 2 hardware pieces. Fortunately, instead of paying for the phone line, you're now just paying for an adapter, but you're still paying some money to do this. And you're still limited by what your provider will support. So if you have like a Time Warner cable modem in the state, basically Southwest, where they give you a free phone line, this kind of is actually what started Druid's war dialing project was, hey, I've got a free phone line. What am I going to do with this thing? I don't want to use it. Okay, I'll just war dial forever until I cut it off. Okay. So that was kind of the methodology behind going through this. So the software's not really quite there yet for war dialing, and that's kind of what got Druid starting with ATAs and things like that. But if you want to do direct voice over IP war dialing, there's iWar, which has had really basic support. It's actually gotten a lot better recently. And there's IAX modem, but that can only really handle faxes on the DSP side. So if you want to war dial with Metasploit, so Druid started working on this stuff. I got all excited about war dialing again. I was reliving my preteen adolescence, whatnot. So I went and got a USB modem from Fry's, which seems wrong all by itself that there's not an RS-232 on it. Hooked that up. Got a generic dual stack SIP IAX ATA, so it can handle both the SIP protocol and the IAX protocol. The device I got didn't have any identifying marks on it. I bought like the cheapest one I could find from China, and it was like VoIP Gateway. That's it. There was no brand. There was no company. There's no support. There's no documentation. There's nothing but like some ghetto little web server that's probably stolen from somebody else, but it works. It also has no FCC ID, so I don't really know whether I should use it or not, or what kind of power to put into it. Like, there's nothing on this device. So I actually need to start breaking it down to figure out what the hell the thing is. But it works, whatever it is. How much did it cost? $25. So that was the price. So if you want to start using the war dialer Metasploit, if you saw Druid's talk earlier, you already know how. If you don't, basically check out Metasploit's SCVN snapshot. Use auxiliary scanner, telephony war dialer. Make sure you have at least one modem set up on your device hooked into Metasploit, and go to town. And if you need an ATA, if you need like a VoIP provider, you can find one of those for your adapter. So the reality check on these unlimited ISPs, like Magic Crack and all those other folks who sell you little unlimited dialing lines, is that they're not really unlimited. They limit you to one outgoing call. You're limited to about 250 total destination numbers, and they charge you basically $40 a month for it or $25 a month for it. And they have really aggressive policies on auto dialing. So if they see you doing like crazy amounts of numbers all the time, they'll cut you off. And some of them even go so far as charging you $100 per call you make after you reach your 250 destination number limit. So you just get screwed on charges. So read your contracts really closely if you want to use one of these with the war dialer. There's also contract locks, like this Toronto ISP I was using for a while said, oh, if you sign up for us, you're locked in for 1.5 years at this rate and this and that, and I finally got out of it, but it's a pain in the ass and it was hidden in fine print. So all the per minute ISPs look like they're more expensive at first because they charge you per minute, but keep in mind, the minute charge only starts when your call connects. So if you dial 10,000 numbers and only half of them connect, you're only paying $50 if you disconnect within 1 minute. And there are some little tricks around that, but basically it's not that expensive to dial huge exchanges with the per minute ISPs. They have better protocol support. The staffing people aren't idiots. You can usually do up to like 10 plus outgoing calls at the same time, which is really nice. I've got one ISP that I've done up to 150 concurrent calls through at once, and they started like actually shutting down their own switches and all sorts of things, but they took it anyways, and they took their money, and they're happy. So basically all these folks are really happy as long as they get paid, and they're really set up for bulk services. They don't really notice war dialing patterns. There are some hidden fees. Vitality.net, for example, they round up to the nearest 6-second block, and they include the ring time in the count, but only after connection. So if the call rings for 30 seconds and then it connects, you're already 30 seconds into your call. And if you're at 31 seconds into your call, they round you up to 36. So just keep that in mind when you're doing your testing, that they will actually round you up. So the default timeout in Warbox is 53 seconds to avoid this problem. But you only get 20 seconds of audio because of the normal ring time. So basically, starting off with a standard boring war dialer, I did 48 hours straight of dialing, covered about 2,000 numbers, found all these carriers. I found what I thought were 4% of carriers, and they're all these weird 300 baud tilde question strings on the screen. Ends up, that was just my VoIP modem being stupid, my modem and my VoIP ATA being stupid, and thinking that a fax machine was a carrier, and being confused. So if you see a whole bunch of 300 baud connections over VoIP connection, that's why. So one of your devices sucks. So basically, it's about a 45% answer rate, and this is how it's panned out, and about 4% of all the lines that I dialed were carriers. So I spent basically 48 hours to only find about 100 carriers that are mostly really fax machines. And I spent about $13.25 on it. So I was just generally pissed off that this whole process was really inefficient and horrible. It's like, dude, this sucks. I can do way better than this. So then I got all crazy on it. I'm like, all right, screw this hardware, screw the modem, screw the ATA. I just want raw audio. Let's get this done another way. So I wanted to do a raw software modem, actually hooking up a DSP to the VoIP provider and the audio codecs and doing straight up like V90 over VoIP. But I'm a really poor programmer, and I suck at math and coding and DSPs and shit, so I gave up on it really quick. I tried using IX modem, but it was smarter than I was, and it can only do fax. iWar was really nice, but it wasn't really fleshed out because the client library they call had some bugs at the time, so Dabib didn't really finish it up yet. So I kind of stepped back and said, okay, there's the problem with what I'm doing isn't that I've got bad hardware or I can't code. The problem is that only 4% of the devices out there are actually modems or faxes. So what's the other 96%? And there's got to be something cool in that other 96% of the numbers. So half the fun of ToneLoc back in the day was sitting there in front of a bank of modems listening to all the random audio, because you turn the sound way up so you can, kick back and laugh at it all. The person calling the phone going, what? Who's calling me? Stop calling me, you kids. So that stuff was a lot of fun. So it was a lot of fun to go through all the audio and that kind of crap and listen to the callbacks and manually classifying lines that you thought were really interesting and cool was a lot of fun. And you found all sorts of weird things you would never ever find in a normal Word doc. Like you'd find the voice prompt to GT wireless gateways. You'd find menu systems for the back end of radio transmitter stations. All kinds of really cool stuff. So WarVox was kind of the solution I came up with. We call every single number via voice over IP. We record an audio sample of at least 20 seconds. We process the audio later on, and then we move on to the next number. So this is super, super scalable and cheap. Even for uncompressed codecs like ALAW and ULAW, you're looking at 80K per connection. So you can basically do, how did I do the math on this? I think it came out to something like 1,000 concurrent outbound dials at a time from a normal home ISP or home cable modem. Because it's all downstream traffic. You're not sending anything back out. You're not talking on it. You're just recording the audio. So since it's all downstream traffic, you can dial like mad on these things. And plus, you have archive audio. So now you can go back and say, okay, what did this number sound like at 3 in the morning on this time in this date? Was someone home? If the person home, was that a guy picked up? Okay, was the guy picking up actually the husband? So there's lots of cool information you can actually start building based on dialing information, this dialing stuff. So basically, it comes down to the components there's one little C app that's crappy that I wrote called IX Record. It dials over IX, saves the raw audio file, and that's all it does. Then there's a Ruby on Rails web UI that actually provides like an interface to actually schedule your jobs, run your jobs, stuff like that. And this does configure your providers, launch your dial jobs, get the audio classified, etc. And then there's a bunch of back-end Ruby code that actually does the processing and audio files and things like that. So if you combine a whole bunch of voice over IPs at the same time, you can scan like 10,000 numbers in about 3 hours. So it becomes crazy, crazy fast to start scanning anything you want. Doing this, though, if you go over about 100 lines at a time, you'll start shutting down small cities' phone switches because they can't handle the traffic. So I managed to actually overload a switch in Moscow, so it just dropped the entire exchange when it was mid-dial. They kind of went offline. I was like, wow, they really need to upgrade that switch there. But it's the kind of DOS stuff you normally wouldn't think about in the normal course of business, right? But you can find a lot of really cool things. It's really resource intensive because once you have all that audio, you have to go crunch on it. And since I said I can't code, it's basically Ruby doing like DFTs and FFTs and crap like that. So it's awfully slow. I still call C for like the grunt work, but it's still doing a lot of BS in the background of conversions and stuff. And I can't code, so it's slow. So if you want to optimize this crap, great. My solution is just to throw more hardware at it. So I run it on an 8-core Xeon and say, I don't care how long you take, just get it done. So it's the lazy man's approach to speeding up software. So when you actually start looking at these audio files, what you see is just by looking at the audio graph, you can see that a lot of calls look the same. Like, hey, this is the waveform for this audio, and they all kind of look the same. They probably all sound the same. So you can actually start visually identifying different things. And Efrain Torres talked earlier about WMAP. He was helping me out early on trying to find different algorithms for finding ways to match data and automatically classify stuff. So that's what I'm talking about next. Hopefully I can get through this and give Egypt some time still. So this is what a voice sample looks like. Blah, 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 blah. Kind of an automated response. It doesn't wait for you to say anything. It just goes. Here's what a fax looks like. Wee, 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 wee. Kind of the squealing noise and all that crap. So this is it. You can see the bars of the annoying noise. Here's a human, because they get really confused. They get a random call, and they go, hello? Click. So that's a human. The problem, though, is modems sound a whole lot like faxes. When you actually start hearing this squealing noise, and some people are like, freaking Rain Man. It can be like, yeah, man, that's a modem. That's the 3200 baud V2 BIS running on this type of system on a max access rack with this and this and that. I'm not that person, but if you find them, hire them because they're cool. So if you look at the fax, here's kind of how it's split out. If you actually look at the detail without all the fancy lines. This is all just done via NuPlot, by the way. I don't have any crazy graphic skills either. So here's a fax. Here's a modem. So just by flipping between the two of them, you can kind of see there's a pretty significant difference of just what these things look like. Unfortunately, when you actually start getting down to the audio, the frequencies they use are really similar. They both have carrier frequencies. They all basically hover around 21 hertz for their peak frequency. So what I found out is not only, so I ended up wrapping the KISS FFT library for doing FFTs in C, in Ruby, so I can crunch it. But basically, modems always have 2250 hertz, and nothing else does. So if you find more than about 1 second of 2250 hertz frequency anywhere in your entire audio sample, it's almost always a modem. And that's worked out almost perfectly. If it's anything else and has a lot of 2100 hertz, it's probably a fax along with 1625, 1660, 1850, etc. So the neat thing is, okay, now I've got these giant lists of modems that I pulled out of dial-up pools, out of the POP list for all of AOL. I basically dialed every single AOL access number in the US and then compared all the audio to see what they look like. So I dialed all these, I checked the signal amplitude, I checked the frequencies, I kind of looked at the different patterns. Basically, you'll see exactly 3 different visual patterns pop out and 3 different audio samples and 3 different carriers. When you actually connect to it, you get different login prompts. So all of the AOL dial-up numbers in the US only have 3 different login prompts. And you can tell which ones they are just by looking at the audio from the sample without ever connecting after you fingerprint it. So here's an example of amplitude graphs. You can see all the little fat guys, the really fat long guys, are one. The little short stubby guys are another, and the kind of long skinny guys are another. So just based on this, we can see what brands of modems are in use across all AOL's POPs in the US. So you can start identifying actual audio by looking, identifying actual hardware by looking at how the modems are configured and what the audio looks like. Here's the frequency graph. It's tough to see from back there, but there's really only 3 different frequency charts here as well. So the next tier, okay, so we can do modems, we can do faxes, we can figure out some of these tones, but how do we actually do voice? Because I want to say not only is that chick hot, but how old is she? Like, how high is her voice? I'm actually married and have a kid, so I'm not actually that interested for that reason. I think of it more of as a abstract reason that, it'd be interesting to see what they sound like. So it's also interesting to find out how old someone is based on their voice, based on this, based on that. You can get kind of a, anyways, you can start classifying people by voices and by samples. So the first way we did it was super ghetto-tastic. And Fran and I worked on this thing that looked at the silence versus noise gaps in the 8K audio stream. So how much noise is there, how much silence, how much noise, how much silence. It was super crappy, but we don't know math. So it worked. So we're like, hey, it did some stuff. So we found that carriers and tones have very few transitions because there's beep, silence, beep, silence. Voice systems that talk a whole lot have a whole lot of transitions. And humans are mostly silenced with 1 or 2 little really short blobs of noise in between as they go, hello, hello, stop calling me, you asshole, stuff like that. The only problem is these signatures fail for time-shifted audio. If your sample starts halfway in, like half a second into the person saying the same thing again, it doesn't detect it properly because it's just the way the code worked. So before we figured that the time shifting broke it all, we started matching every sample against every other sample to automatically group stuff based on how they sounded. So I'll show you some of the actual graphs later on about how we automatically group these things. And I'm short on time, so I'm going to haul ass. So basically some fuzzy matching, we found some things that sound the same, like you can find all your, this call is being answered by Audix, or welcome to IBM, or whatever the noise happens to be. You can kind of match up all the prompts together. So we wanted to have better analysis. We actually write signatures for any 2-second chunk anywhere in an audio stream. So we took every 1-second audio sample, took the top 20 frequencies from each one, sorted them by power, created a fuzz amount for up and down this much of frequency, up and down this much of power, and then matched 2+ samples anywhere inside of the top 20 frequencies. So this avoids the time shifting issues because the fuzz factor allows you to catch signals that have been warped basically by the time shift. And you can match any kind of pre-recorded audio segment really easily just by scanning for, anything you've heard before you can find again basically. And you can always rerun your processing after you've done it the first time, each time you update your signatures. So you dial once and then, keep tuning it to identify every single little bugger on the line. And that works really well for any 2-second plus audio sample. So basically we match every sample against every other sample, look at basically every 3-second offset from any source call, and you can create really neat one-to-many matches, really slow multi-to-multi matches, but you can basically automatically group lines that have the similar sounding signatures inside of them. So if every line is answered by Audix, if everyone's a Verizon, AT&T, whatever, you can make them all grouped together based on what vendor, what audio sample they actually have inside the line. You can also match them all based on peak frequency, and I'll show a graph of that later on, and that actually does a pretty good job, but it misses chances when there's any other louder tone on the call other than that peak frequency. You can also group by matching signatures, and we'll talk about signatures next. So the practical piece of all this is you can identify similar voice recordings. Anytime that a company has a standard response, anywhere inside the audio stream for as long as you record, even if it's 10 minutes into it saying, are you still there? +5 to hit blah, blah, blah. You can actually record that and fingerprint that anywhere in your samples. You can target specific PBX vendors. So if you know that a VIA system has this default password, if you know that this kind of mailbox allows you to do a bounce through and dial through their system and start doing toll fraud, you can now find all those devices really easily. So you can actually find some really neat things. You can look at all things that don't match and say, okay, what the hell is this thing? It's actually a U.S. phone number forwarding to a UK number, but you can hear like kind of like, flubby ringtone, the brr, brr, brr. So you can actually pick out different countries' ringtones and forwarding lines based on the sound. You can find all sorts of really neat things this way. The problem with the voice signatures, though, and doing automated response is this woman. This woman is a problem with all of my voice signatures because she recorded all of them. This is Pat Fleet, or also known as like Ma Bell's voice. She recorded like 90% of all the audio you've ever heard on an automated response system out there because everyone loves her and loves her voice. Unfortunately, because her voice is so similar each time she speaks, the signatures have a really tough time figuring out, based on frequencies, whether it's this tone or this tone or that tone. So anytime I run into her in a signature, it conflicts with every other signature by her as well. But keep in mind that because this works so well in this sense, you can actually take a recording of one person's voice saying hello and then scan an entire city trying to find them picking up the phone and then nail their phone number that way. So there's some really nice, cool Uber stalker things you can do with the system. But you can always find Pat Fleece. So we want to start hacking voicemail. A gentleman right before I started talked about this. Basically, if you have a system that allows you to do caller ID spoofing, most VoIP providers allow you to do this. Most mobile providers in the U.S. actually allow you to bypass authentication if you have the same caller ID as the caller, as the target line, and unless you've got a pin set that goes straight into it. So the cool thing about this is you can actually create a signature for welcome to your voicemail, or you've entered Verizon messaging or AT&T, you've got one new message, and actually start scanning huge blocks of numbers using their own caller ID as the source for it, and basically determine which of your salespeople or which hot chicks in this geographic area don't have passwords set on their voicemail, and then go into their voicemail and then change their greetings. So it's fun to do. And you can basically mass audit your entire sales staff or your executive staff using this method. So most iPhones are screwed, most Verizon lines, all sorts of cool things. So I've been doing a bunch of mass audits, and I'm out of time, so I'm going to haul ass again, but I can do a demo later on if there's time. And the nice thing is because this whole thing runs on a web interface, basically Ruby on Rails, you can actually do all the dials from your iPhone over 3G. By going to the web interface and basically running 150 plus dial scans directly from concurrent line scans from this. So you can go into the building and make every single phone within a mile of you start ringing at once. It's a lot of fun. So there's all sorts of fun little uses of this thing outside of just, you can really just annoy people with it. But besides annoying them, you can also do signatures. A friend of mine got a dial the other day. He had no idea who it was, so he dialed every line of 20 of the person that called him and found out it was actually some bill collection agency by finding one of the other lines besides the one that called him. The one that called him, if you return the call, it says, this is the Children's Cancer Health Foundation or something like that. But really, one of the other lines was, we're bill collectors for every other line. So the way they trick you is that when you call back the bill collector, they think it's a Children's Cancer Foundation donation center. But it's really a bunch of bill collectors using spoof voicemail. So anyways, so you can actually track those buggers down using Warvox by calling all their lines to figure out who the hell called you. Anyway, so you can start displaying some of these groups using canvas objects in HTML5, a lot of fun. So here's a group by silence versus noise. You can see big stripes of similar colored audio that were automatically grouped using the very first method that we came up with. Using this method, you can see another set of stripes, and actually you can see between these two, there's completely different patterns. This one's grouped by peak frequency of the call, and this is grouped by which ones sound kind of the same through silence versus noise. So peak frequency means anytime that there's a really loud noise on the call, if that was the loudest sound on there, all the calls that had the same thing would basically be grouped together. So this big stripe of little pink suckers right here in the middle, or red suckers on the screen, those are all voicemails. And that's actually the beep at the end of the voicemail. That's about 1,000 hertz, and it's louder than whatever the person said. So you now group all the voicemail guys together just by the peak frequency alone. So all kinds of cool things. You can do spectrum analysis. You can find tones. You can do this. You can do that. Here's a frequency challenge. If you've seen the presentation before, you're disqualified, and I already gave away all the vodka that no one picked up last time I did this. So what is this? 350 plus 440. It's a one solid tone. It's easy to pick up. Sorry? I heard it over here. Dial tone. Yes, absolutely right. That is a dial tone. So what you can do is actually start looking for dial tones across all the calls, and you find forwarding lines where the line goes to a dial tone here, and then here as it dials back out again. Well, you can actually look for those dial tones and race the forwarding line. So you dial the number, and you immediately in your VoIP call basically send DTMF tones, and that makes it the forwarder dial whatever number you want, not their number. So you can also just find straight up dial tones. Like half of Korea is covered in these things. If you dial all of South Korea, every fifth line apparently is a dial tone you can dial back out of. I don't know why. Maybe it's just misconfigured telco or something, but it's a lot of fun. So you can also find things like UK ringers, US ringers, busy signals, Russian voicemail, all based on the combination of tones. So lots of Russian voicemail systems use 1420 hertz. Busy signals are 40 plus 620. US ringers are 440 plus 400. And you can pick all these out really easily. You can also do DTMF decoding using Luigi's tool, DTMF to num. So if there is a DTMF, like, you can actually decode and see what the actual numbers were. And I've integrated with Lumenvox to automatic transcription of the audio, so you can actually pick out certain strings. But it doesn't work that great yet. You can integrate this asterisk to do automatic testing. So I took the AGI script from Debeve and iWar, so I can actually automatically return the same audio to my dialer from a directory of pre-recorded samples, so I can actually automatically test my audio signatures in my dialer. So moving forward, 101 is public, 102 is an SVN, lots of really cool features. Check it out if you haven't already. Legal aspects, you're all fucked. Look online if you care. Basically, you can't dial in the US without potentially risking breaking the TCPA that was amended in 2003 because of EFAX. But there's kind of a legal page at Warvox, you can look at it. But look at your federal law, look at your state law, and if you have city statutes about it too, look at those as well because they all apply. I'm not going to do a demo because Egypt stuff is cool. Thank you for your time, and please welcome Egypt to talk about Interpreter PHP.
Through that was awesome.
Sorry, no, I was trying to get right in.
Yeah, no problem. I'll have plenty of time. Don't worry about it. Okay, so Scape's original talk about Interpreter was called Beyond EIP, and this is beyond R57. Brief outline, PHP has a bunch of stuff we can use. There are a bunch of existing PHP payloads that we'll talk about shortly, and some of the stuff that's already in Metasploit that we'll talk about, and encoding and how we deal with some of the problems writing PHP as a payload. So running some system commands is relatively easy in PHP. There's a bunch of ways for a system administrator to take these functions away from you, but there's so many of them that I don't care. I'll just use a different one. There's system, there's exec, there's shell exec, there's pass-through. There's others based on third-party tools. There's actually a freaking Perl interpreter as an extension for PHP. I mean, really? Come on. There's things for administering Windows through PHP. There's a Win32 service extension. So you can start, stop services, you can create services, you can write files, you can do whatever the hell you want because it's there intentionally. Opening sockets is basically the same way. There's a whole bunch of different functions that do it. Socket, fsock open, pfsock open are all built-in functions, and they all do exactly what you think they do. The best part is that they're not the only ones. fopen, which you normally would think would open a file, right? Well, it can take a file called http://blah-blah-blah.com, and it actually opens up a bloody socket. That's so cool. If that doesn't work, if all of those functions are unavailable to us, but we can still run system commands, then, well, we fall back to Perl or Netcat or Bash or Ruby or anything that'll let us create a socket. There's all kinds of stuff that can let us talk out to the network. Another cool thing that we can do is reusing Apache's sockets. It's not really available for any other platform at the moment, but Apache fails to set the FD cloexec flag on any of its file descriptors. So when you connect up to it, you keep that socket in PHP, and you can read and write to it, do whatever you want. Freaking cool. There's a bunch of existing payloads. In my opinion, most of them suck. C99 and R57 are sort of the big guys. They're the ones that everybody uses. They're the ones that you find on pwned web servers all the time. R57 has this giant chunk of base64 goo at the bottom of it. And if you actually go through and decode that, it sends a shell to Russia. Really? Okay, so there's also tons of private stuff. Everybody's got their own PHP shell because it's really easy to write, and a bunch of them are really simple. They're just a form that runs the command and gives you back all your feedback over HTTP. I think that's kind of boring. So we've got all this other stuff. Why make something better? Basically, I don't want to have to use HTTP. I want to be able to use a real socket, or using Apache, we can use the socket that already exists. And as I said, R57 especially, but others, a lot of the public ones have backdoors in them. That sucks. Like, if I get a shell, I don't want to give it away. That's my shell. You can't have it. So these are the Metasploit payloads that are currently available. I committed one about a week ago, or several days ago, for download exec, which lets you go directly to like a interpreter shell in Windows or whatever. But that's not quite as interesting as doing everything from PHP. So I'm working on getting that together. There's still a few problems with it. I'll talk a little bit about that in a second. But for the bind shell, it's really easy. There's a socket create listen function, and it does what you think it does. It creates a socket, and it listens on it. So we can do that, and then just run system commands, and we win. If that doesn't work, there's socket create, socket bind, socket listen. That does exactly the same as a regular, the C system library calls socket, bind, and listen. So the problem is that this isn't exactly a shell. I'm basically creating a new shell process for every command, and for the most part it's okay. It works fine, but CD doesn't work, for example. Reverse is basically the same way. We can use socket create, socket connect, shell. If that doesn't work, we've got fsock open. If that doesn't work, we can use pfsock open. If that doesn't work, we can use curl. If that doesn't work, we can use the Perl extension. So anyway, the problem with this is that there's two different kinds of file descriptors basically in PHP. The stuff opened with fsock open or fopen, you have to use fwrite, and the stuff opened with sockets, you have to use socket write. So that's kind of a bummer if we're doing both file and socket stuff, because we can't select on both of them at the same time. So that becomes sort of an issue with Meterpreter, but reverse so far, just creating a shell is relatively easy, and we don't have to worry about that problem. FindSock, like I said, only works on Apache on Unix systems because it doesn't set the cloexec flag. PHP says that this is an Apache bug. Apache says this is a PHP bug. So I just think it's an awesome bug. Conveniently, this lets you write to their log files because they leave all of their sockets or all of their file descriptors open. So you can say, hey, I love owning your system, right in the middle of their log file. And who doesn't like writing stuff like that? And unlike bind and reverse, this is a real shell because I'm actually calling out, making a new SH process, and running the whole thing over the socket. And this is what it looks like. I think this is totally cool to be able to type directly into a netcat session and it actually be a shell on an Apache box. I think that's totally awesome. So PHP has a number of ways of screwing us. The first is disabled functions, and that's a setting in php.ini that will basically turn off those functions, and you can't call them. Fortunately for us, a lot of PHP administrators don't know about it, and they never set it, and so we can just run rampant and do whatever the hell we want. For those that do, there's not a whole lot we can do other than just trying all of the other things that do what we want to do. Most people in their disabled functions list miss one or more of the socket functions. They miss one or more of the system functions. As long as we've got one of them, then we're good to go. Another big problem is character filtering. Magic quotes is a huge pain because it doesn't let us use quotes in like an eval payload. And we want all of this stuff to be as transparent as possible. We just throw up a blob of PHP, and I don't care if it was an eval bug or a file upload bug or a remote file include. I don't care. I just want it to run my code. I just want my shell. I don't care how you do it. SSL can sometimes be a pain in the ass, but I mean, on the server, SSL can be kind of a pain in the ass. But also, SSL is a pain in the ass because it's now implemented by default in the the normal interpreter handlers. So when HD made that commit, it broke all of this stuff. Eventually, we'll get that fixed. We'll have that all together, but that's not quite implemented yet. So yeah, disabled functions if we don't have system, try exec, etc. And filtering is sort of easier to get around. Unless we don't have parens or semicolons, we win. Because you don't really need quotes. It turns out that PHP parses bare words first as a constant, and if a constant doesn't exist by that name, then it tries it as a string. But the advantage here is that we don't need any quotes at all. So we can just create this big chunk of what looks like a string as long as it doesn't start with a number and contains only numbers and letters, then it'll be parsed as a string. There's a 998 character limit here. I assume this is something to do with PHP's internal representation of identifiers. Because it's parsed as a constant, it counts as an identifier, and so it falls under all of those restrictions. So that means it can't have a dash, it can't have a plus, because those are other operators inside PHP. But it's not that big of a deal because we can just put everything in base64. And base64 has slashes and pluses, which kind of sucks, and equal signs. But we can just turn all the slashes into chur43s and all the pluses into chur47s, and it becomes the string that we want it to be. This increases all of our payload by about a third, but I mean, it's not shellcode. Who cares? It goes in an eval or it goes in a file include. The size doesn't really matter. So yeah, like I said, Meterpreter is now a lot better because of SSL, and we can hide our shell on a Meterpreter session much more easily now. It's a lot harder to find it on the network, but I don't have it in PHP yet, so it's broken. The Meterpreter is still a work in progress. Most of the core stuff is there. We've got process execution, but because I haven't finished figuring out how to make channels work, we can't see the output of an execution. So if we run a system command, we can't see the output from it. You can write it to a file and download the file, and that works just fine. But there's no interaction. So you can't, at the moment, you can't do just a regular shell and start typing in the shell and have it give you your feedback right away. There's also no pivoting yet. All of that is coming, but there's, like I said, the problem with PHP's select and the difference between its file descriptor types makes writing channels kind of a pain in the ass. So that's coming, but not for a while. Filtering has, well, that's the wrong way. How much time do I have here? Oh, sweet. I've got time for demos. Awesome. Okay, so So we've got just this simple little PHP script. I don't know if you can read that. The important parts here is there's a remote file include bug there. There's a remote file include bug there. There's an eval bug there. Can you still read that? Yeah, it's not too bad. So we see we're just sending some code to be evaluated here. Now we set our host is set correctly, port is set correctly, set payload, PHP shell find sock. And with any luck here, as long as I didn't piss off the demo gods earlier today, yay, we have a shell. And all of this is going over the same socket as the connection happened on. So all of this is definitely going to go through a firewall. Some IDSs might be able to pull this out because it doesn't really look like HTTP traffic anymore. Once you start typing commands, then it looks more like commands than HTTP. But it's still all over the same socket. It's definitely going to get through the firewall. I think it's awesome. So we can also create a Linux reverse shell payload. Using MSF payload, we create a file called reverse TCP. I'm being lazy here and hosting it from the same web server I'm about to exploit, but pay no attention to the man behind the curtain. So we can set the payload now to PHP download exec. So we're telling it to go download this binary, save it to disk, run it, and give us a shell. Hopefully. Oh, right. We have to set up a handler because there's no handler for download exec. So oh, hey, it gave us a shell anyway. Woot. I don't know. Has everybody in here seen a handler before? Anybody hasn't? Okay, well, I'll just talk about why that's important here right quick. A handler is basically just a generic thing that'll catch an exploit payload coming back. It doesn't really have any options of its own, so we set the payload to be whatever we created that file to be, that executable that we're sending up. We set up all of the same options that we use to create that file. We run the handler, and that'll, let's see. When we run the handler, it will set up a thing to catch our shell, basically. So you can see here we're not listening on 444. Except I wanted that to be -J, -C. So the -J means run as a job, and that'll put everything in the background. And the -Z means something useful. What does -C mean? Oh yes, don't interact with it right away. So we're running the handler in the background. We're ready to go. So if we go back and use our download exec payload again, woot, there's our shell. And we can interact with it in the normal way or not. Okay, well, the payload failed, but it got there at least. So yeah, those are the PHP payloads. Are there any questions? Okay. Well, thanks.